Hello people, my name is Ayush and today we are going to cover Java in one shot. The course is originally designed for Chandigarh University students, even if you are not there. We are going to complete the whole Java in one shot. We will be doing theoretical concepts as well as we are going to do the practical concepts so that you can ace that exam. Even if you are not in Chandigarh University, don't worry, you can still watch the videos because we are going to do everything. You don't need to know anything about programming. I mean, just a little bit, pseudocode and all. That is all, loops and all. But we are going to cover everything from the variables to arrays to control structure. So you don't need to know anything. I'll be going through, and I'm going to go through. Just for a background, I am also a student in Chandigarh University from the very start of my ninth, and I have done quite a lot in it. So let's just see what we are going to cover in it. We are doing Java fundamentals, features of Java, OOPS, JVM, bytecode, Java architectures, variables, arrays. We'll also be covering Java classes, exception handling, input output, multi-threading, graphical user interface, and database connectivities. So this is how it is going to work. We are going to do everything. For example, AWT and Applets, how HTML works, how we can develop everything. And I'll be drinking a little bit of coffee in between because I get thirsty. Plus, get yourself some coffees and we'll cover it in one shot. Let's go, people. So, first of all, let's create a Java file. Okay, we'll be starting, we won't be doing theoretical first because I think if we do theoretical later, it'll make more sense. First, we'll go and code a little bit. Okay, so I am here in my Visual Studio Code. You need to download JDK and JRE. You can do it from Java's website, Java for Windows. I am on Linux, so I got Debian. Okay, you can install, you can watch another video for it. But if you are not comfortable and if you don't want to install it, you can always use online compiler, Java compiler. Just do that. Uh, the internet is a weak. You can use programmers. That is a good compiler and everything. But I'll have installed Java in my local machine, so I'll be using that. So I hope you guys have brought your coffee. So now we are gonna start with the features of Java. The first feature is it is very simple. It is a high level language and it is easy to write. So it is a simple language. The second feature is it's completely object oriented. Okay, so you have to have a class and an object in it. It sounds like you have to have a class and an object, and since it is object oriented, it is very suitable. It reduces the code frequency. You don't have to write as much as code as you have to write in procedural languages. So it is completely object oriented, and you have to have a class and an object. Okay. Then it comes Java is portable. Okay, you can run it on any device. Okay, Java can be run on your smartphones, on your PCs, on servers, everywhere you can run Java. So it is very portable, and also it is platform independent. Platform independent means you can run it on any operating system. In Java, we have a concept of JVM, Java Virtual Machine, which actually makes it really platform independent. Now you'll be like, Python is platform independent. We can run Python anywhere. So we'll get deep into it, and I'll tell you how Python is different kind of platform independent. Java is really platform independent. Then comes the concept of security. Okay, Java is really secure. Java actually, while it is compiling, it checks for memory leakage. Okay, it warns you if there is any memory leakage or that thing. While it is compiling, it checks for memory leakage. That makes it really secure. Then comes robust. Okay, since Java does not provide the functionality of explicit pointer. If you guys have ever coded in C or C++, you'll know that we use the concept of pointers, where a block of we can point to a block of memory, address of that memory, and the program will go there and read that memory. Okay, in Java we don't have those pointers. The Java uses them implicitly, then explicitly we can't define it. So that reduces the chances of memory leakage and it becomes really robust. Okay, your programs would randomly go and crash if you have defined if you have wrongly defined a pointer, your program won't crash because it doesn't let you do that type of shits with the code. Then Java is interpreted. I mean, you compile it, but there is also interpretation. We'll cover that all while we are talking about the architecture of Java. And it is really high performance. Okay, it does not consume that much of RAM. So it is really used for mobile app development. So because we have less of a RAM there, so we need to compile it really easily, and it is high performance in that sense. And then comes multi-threaded. Okay, just a sec. In Java, we have various threads. Okay, Since there are multiple threads, we can perform multiple actions simultaneously. Like if we have to add inside a for loop, if we have to add, multiply, and divide in three statements, it can run those three statements simultaneously. Okay, I'm just giving an example. This is not how it works. It have a complete system to define how multi-threading works, but we are going to cover that too. And distributed and dynamic. So these are the features that you can write in your exams, and these are really the features that makes you want to learn Java. Now, since we have covered the features, now let's cover a little bit about object-oriented. So features of object-oriented, there are objects, classes, inheritance, polymorphism, abstraction, and encapsulation. Okay, these are the main features of OOPS, why we use object-oriented programming languages. Now, why do we need OOPS? Actually, we need OOPS because we are writing a lot of code. Okay, if we are writing a procedural language or a scripting language, we are writing a lot of lines. Okay, since you have to perform a function, say you have a lot of things, you have to write a lot of code and it becomes redundant and everything. So to reduce those things, we have OOPS. In OOPS, we have classes. Okay, now let's see. A class is something that is a blueprint of storing data. If you have ever written in C, you might have known those struct, no? Struct keyword that lets you define your own data types. You can use integers and different things in that. It's a similar concept in which we have a class that is a blueprint that defines how we are going to store data and what sort of behavior that data will have. Okay, so for example, if you think a dog, okay, the lamest example of class is a dog. Okay, a dog will have legs, eyes, ears. The same thing will a cat have. Okay, so we have animals. They all are going to have four legs, two eyes, and two ears. Okay, we can create a class as animal, and then it have two objects. One is dog and cat. Okay, this is this. And we are going to talk about real world examples for login. Okay, for example, let's talk about a real world example. Okay, let's see. You go to a website, say Facebook. Okay, now disclaimer: what am I talking? It's not sure that it is implemented on Facebook or everywhere, but I'm just giving you an example. So you go to Facebook and you create your account. Okay, so what they will have is they have a object named as user. Okay, now every user will have a name. Every user will have an email address. They will have a password and everything. So they'll create that blueprint that the user will have this, and it can have and it can store different values in it. So that blueprint is what a class is. Now, inside that class, now we'll talk about object. Now, object is the instance of that class. Now, let's talk it. Let's go a little here in it. So, for example, we talked about that user in Facebook. Okay. Now, for example, me, I am an object of that class. Okay, I have a name. My name is Ayush. I have an email ID, and I'll have a password to log in. Okay, so when we create that object, it allocates memory to it. Okay, since class will not have a memory to itself, whenever we create a class, it does not occupy any memory. Okay, object operating system does not allocate any memory for the class. Okay, it is a very important point. Operating system will never allocate memory for a class, but when you call that class and create an object of the class, then the memory will be allocated. Okay, then comes the concept of inheritance. Inheritance simply means there is a parent class and then there is a child class. Okay, so now, for example, I can inherit money from my father. In the same way, for example, there is a class that have let's see what can we inherit. Okay, for example, there is a class that is okay. Let's talk about Java. Okay, in Java, strings are not a data type; they are a class of array. Okay, so now array is something that stores simultaneously data. For now, just know that is array. So now string is also the same. It stores data. It stores character simultaneously, in consecutive memory blocks. So that string takes that feature from array that it can store data simultaneously. It takes that feature from array. So let's go deep into inheritance because it is a good concept. And what happened to my internet? Just a second. I don't know what happened to it. Let's see if I can get it back. Okay, work. Why is this happening to me? I think I got it back. Yeah. So you can see there are three terms mainly used: class, subclass, child class, and parent class. Okay. So what child class is that inherits from the parent class. Okay. So in our example, that string is the child class and the parent class is the array. Now, this child class inherits a feature from parent class. Okay, so now the parent class that is array have a feature of storing memory, storing data consecutively. Now that feature is inherited by the string class here. So the syntax to do this is simple. You can just do class, subclass, and this. We're going to talk deeply into this. We are going to cover every concept, but I went too deep into it. Okay, the same thing is polymorphism. Polymorphism means different ways of performing the same task. Okay, now I can speak, a dog may bark like that. That is polymorphism. Abstraction is hiding data from user. Okay, abstraction means just showing the data that is required for the user, and encapsulation means a way of giving data of storing data and the functions of the data together. Okay, this is what object oriented programming is. Okay, we are going to get deep into it, we are going to implement it and everything. Now we are not going to go to JVM directly and Java architecture. I think before we go there, we should code a little. That will give you a clearer example of how we can do this. Just a second. So guys, I am here in my Visual Studio Code. I have Java installed locally on my system. If you want to, you can install it locally on your system. I'm not going to tell you how to do this. Just Google how to install Java. Plus, if you don't want to install it, you can always use an online compiler like Programmers. Programmers is a good online compiler. Okay, I did something wrong. Just Google online program Java compiler. Okay. Now, let's come here. We have this folder where we are going to create a file. Let's call it main.java. Now, one thing you got to mind is this the first name. Okay, this main. This main is what is gonna be used as your class name. Okay, so while we are going to go through the architecture of Java, one thing that is we are going to do is we are going to talk about class loader. Okay, that class loader needs this file name and this class name to be same. Okay, now in this class, we have to create a function. Okay, for now, let's hang in there and we are going to go to the basics first and then we are going to come to this high level thing. Okay, first we have to create a function. So we are going to create a public function, public void, and let's see if it creates a function for me. Function, we call functions methods in Java. Okay, let's call it main. And this always happens to me, public static void. And this is the syntax to declare a method in Java. You use the integer. You're going to tell Java what is going to be the return type of that function, and you're going to name that function that is main here. And then you're going to tell what it can get arguments as. Okay. And the syntax to declare a class in Java is public class main. You can remove this public here, but we are going to keep it there just for the simplicity. First thing we are going to learn is how we can print anything in Java. Okay, for that we just do system dot out dot println, and inside println we are going to write a string, say hello world. The most basic program, anything anyone can write ever, and you never should forget this semicolon in front of this. Okay, save this and run this. Once you run this, you can see this comes here, hello world. Now, let's talk about variables in JavaScript. So let's remove this. Okay, now what variables are? Variables are something that stores a value for you. For example, if you need, for example, you need to store a number of a person. Okay, for that you need to store a value. Now there are different data types. First, we have to declare a data type here. So data types, we are going to come to data types, what sort of data types we have here. But for now, just understand integer is a number. Okay. First, we are going to declare the data type, what sort of data we are going to store. Okay. We are going to store an integer and we are going to name it. Okay. For now, we are going to name it number. Okay. Now let's write a number. Okay. We can call it any number. This is a phone number and we have declared it. And you can see there is a range to integer. You can declare it out of that. So this is what an integer is. So we have declared this number here, that is an integer. Now this is giving me a warning that I haven't used it. So let's just use it and let's print this number. You all know how to do that now. Println, and we can just call this by its name. Okay. Now one thing you have to know is this name should be unique and it can't start with a number. Okay. If you start with the number, it is going to give you an error. Okay. So don't start with a number and just use this number. Okay. Now, let's run this, save it and run it. You can see it is printing that number here. Now there are different types of data types in this. We are going to come over here and we are going to check the data types we have here. So Java data types, we have a Boolean. Boolean means it stores true or false values. Okay. There are two types of data types. One is primitive and other is non-primitive. Just remember this. Okay, these are primitive data types. First, let's talk about data type. Okay, look at this chart. Oh, so there are data types are divided into two categories. One is primitive and other is non-primitive. Now, what you can see is primitive data types are those which are predefined in the system. Okay. Now, non-primitive data types is something that is made of primitive data types. Now, if you see, Boolean can store true or false value. Like if we declare a Boolean array, it consists of Booleans. Okay, it is gonna contain an array that stores true, false, true, false, true, false, like that. Okay, so primitive data types are those data types that are predefined, and non-primitive data types uses primitive data types for their building blocks. Okay. So now primitive data types have two types. One is true false and other stores numeric values. It can be a characters, integers, and anything. Floating points. So these are primitive data types. Booleans, it stores true or false value if you have to ever return true or false value. For example, let's declare a Boolean. You got to write complete Boolean and say Ayush, Ayush male. Okay. Since Ayush is a male, we are going to do true. And it stores the true value. Okay. Now, byte stores a number. It stores number of bytes, like 0101 value. That is this character. Also, a character stores a character. Okay. For example, it can store a. If I do char a equals, I got to use single quotes and this. It is gonna store a. Now, this a is also stored in an integer value. So if I can, it is stored in an integer value. Small a is 96. That is a different thing. For now, in the short video, we are not going to cover that. Then comes short data type. It stores a small amount of data. Then comes integer, the most used data type. It stores any integer. It can, but it does not have floating points before it. Okay. And then comes long. Long stores long. It can store. They all store numerical data. But the thing is, these data types have different storage limits. Okay, that range error we got for integer, they all have different ranges. Some have 256, 64, like that. You got to check that on Google. And then comes float. Float stores floating points. Floating point means it stored decimal values. And then comes double. Double stores also stores floating point, but it have more memory allocation than float. Okay. If you want to, you can come over here. Java Point have very good understanding of it, but you don't have to worry about that much. So these are data types. Now we are also going to talk about data typecasting. Okay, typecasting means you can convert a data type into another data type. For example, let's just comment this. For Java, you have to you can use double quotes to comment, or you can use this method /star to write a multi-line comment like this. But for now, let's remove this comment and let's type in. Let's declare a int. Say int number. Let's call it num equal to 98. Okay. Now what I can do is I can typecast it. I mean, if I want to change the data type of it, for example, if I want to convert this int into a float, so what I can do is I can type in float num equals num, or I can give it another name. In Java, we can't duplicate these numbers, so I am gonna call it num1. Okay, this is num1, and if you see, this is there, and if I do system dot out print ln, and we call it num, and okay, let's call it num1, and let's copy this line, and let's go up here and paste it here, and we call it num. Okay, this is gonna print this. You see there is a 0.0 at the end, which means it's a float. Okay, we can also test the type. I remember type name. Will it work? I don't know. Okay, it is giving me error. I don't know how to check the data type. Okay, this is one way of typecasting. The other way is I can just do this num. Okay, I can call something else. Let's see. This is one way that you store it in a different way, different variable, or we can do this num equals float num. Okay, it is gonna give me an error. So let's do float here. Float num equals to num2. Okay, now you'll be like, what is the difference? Why should we write this? So sometimes what happens is you don't want to actually convert the name, but while showing the data, you might want to round the figure. For example, you want to write if it is initially a float and you want to show it without any decimal value. So you can do this. Okay, let's make it float. Initially it is float, but while you don't want that decimal to come up. Okay, so what you can do is you can just write an int in front of it. So it won't show me the decimal value now. Okay, if you want to see the example, let's do it in a good way. System dot out println. I don't know why Java developers thought of this that it should be that long to be written. Let's do num. Okay, here we have typecasting and here we don't have typecasting. Okay, if I execute this, you'll see it shows without typecasting, it shows 98.0 and it shows 98. Okay, if I do, since it is float, I can do this. Okay, why is it type mismatch? I don't know why Java likes to do this to me. Okay, let's make it double. Double is same as float, but can store more data. That is usually how it works in other languages. Now you can see it shows 98.3, but here it shows 98. So this is somewhat of a practical use of it. Typecasting. Okay, we talked about typecasting, and let's go ahead and let's talk about arrays. Array. Okay, so we have talked about the data types here, primitive data types. Now let's talk about these non-primitive data types. So the first one we have is array. Now let's just let me get a good picture of array. Array images to show you how array works. Hi, this one looks fine. Let's open it up here. It's not clear, but let's see. Okay, so what array does is it stores data in consecutive memory blocks. For example, in memory, you can assume memory as to be this long queue. Okay, this long line that have 7, then 11, then 6, then this. Okay, this is the data that is stored in that particular memory block. Okay, these are memory blocks. They are usually the size of the data type your array is, and it stores it like that. Okay, so 7, after that 11. So what this helps is this have this index. Okay, the first element is 0 and 1 and 2 and 3 and 4 and so on. Okay, so the first index starts from 0. So whenever you write the name of your array at 0th index we have 7, at 1th index we have 11. Okay, this is what array is. Most of you will probably know what array is. Okay, so let's go and let's declare an array here. Declare an array. You just need to do this. Let's declare an integer array. Okay, you have to use these curly square braces in front of the integer data type, and then it's the same. So let's write the name of the array. We'll call it array, and you can use curly braces and use the values like do and this. This is how you declare an array. Now, if you want to print it, just do system.out println and call array like this. Okay. Now, if you want to declare an array statically, means you want to keep and bound to array that this can be this long, you can type in like the size of array. If you want to just show this 5, so this is there. Now in Java, arrays can be dynamically shown. So we are going to do dynamically, and we are going to store these 5 elements into this array. If I call, you can see, okay, there is something of an error. Okay, what is it? Let's shift it to a new line. This is a new line operation. I'm concatenating this string to this. Okay, so for a quick thing, this is what this is used to get your cursor to a new line. Okay, it is used for new line \n plus array means we are concatenating this string with this array. Okay, so they are going to be showed together. I'm going to explain it better. What is this? Why is it storing it like this? 7 1, there is some sort of an error. Why are you doing that to me? I don't know. Okay. Why are you unhappy? It's to float. Still unhappy. And this is the syntax for arrow, right? Why is it unhappy with me? Let's see. This is how we do it. Yeah, this is how we do it. Okay. I remember the wrong syntax. I am using these. Okay, you don't use these here with the float. You use this with array. Okay, now if you do this, it's gonna be fine. Huh? No, still not fine. What the fuck? Sorry. I don't know this. Why is it giving me that error? Okay, let me come back. Okay, so my bad. I usually code in Python, so I was just printing the array, but this is not how it works. You gotta run it in a for loop to print the array. It is printing the base address of the memory. I haven't coded in these languages for a while. I used to code in Python, so I was just declaring that array directly. So what we can do is we can call it at an index. So 0, and let's call it, and it's gonna show me that value at 0th index, which is 1. And for example, if we do this for a while, we can go ahead and print it. So at 1th index, it's 1. So this is the 0th index. This is first index, second index, third index, fourth index. So if I want to do the third index, it will be 5. Okay. Yeah, it should be 5. Yeah, you can see this is 5 at the third index. So whenever it starts from 1. Okay, now if I want to change the value at the second index, okay, it's initially 3. Okay, let's go here. It's initially 3, but I want to change the value at third index. What I can do is I can go to this array, and let's call the third index, sorry, mm, which is 5, initially 5, and I can change it by this. Okay, I will make it 9, and I'll copy this and paste it here. Now I can call this third. This is there. This is there. Let's call it here, and let's see. Yeah. So first it was 5, this value, and then I changed it to 9. So this is how you can change the values in array. Now, if you want to call the whole array, what you can do is you can write a for loop. Okay, we'll come to for loops in a while. So first, let's just stick with me. I equals 0, I less than length, and I plus plus. It's a lot of syntax. Okay, we are gonna come to loops now. Anyway, system, and let's call it. Sorry, what am I doing? Out print ln. Wow, I am writing code like I'm a child. So many errors. Why? Okay, so array.length gives me the length of the array. Okay, so what it eventually gives me is for this array, it is going to give me 5. Okay, it's going to give me 5. So this is 1, 2, 3, 4, 5. There are 5 elements, so it's going to give me a length of 5 elements here. So this is how you call, the length of the array. Okay, so what it is doing is from I to 0 to length, it is going to use every variable. Okay, we are going to come to loops now. It's so hard to explain these things. Okay, so if this now we are going to remove this thing here. Okay, let's leave one thing. Let's print the length of array here, array.length, and let's run. You can see we have been recording for 32 minutes already. So you can see the length of array is 5, and it is printing every element of array one by one. So this is how arrays work. Now, the strings in Java are also a subclass of array. So array is a class, and it have a subclass named as string. So what string is? String is an array of characters. Okay, it have a null pointer at the end. So string is basically a. Now let's come to string. Okay, what string is? String is just a array that contains characters. Okay, so it is a class which is implemented in Java already. So one thing you'll know to to declare a string. This is how we declare a string. Hello. This is the way we declare a string. Okay, str. Now, one thing you'll know that in every data type, like here char, the C is small, this is small, but in string S is capital because it is a subclass of your array. It is not a data type itself. Okay, it's a primitive data type that is a class of array. If you come here, data types, and you see the string is a non-primitive data type, and it is a subclass of array. It's not written here. If you see, it should be somewhere here. Okay, leave it. Just believe me. Now let's go. We have covered this variables and arrays. Now let's go to loops. I've covered strings as well. I'm just checking it in my notes. Let's go to control statements. So we have different control statements: if else, switch, for loop, while loop, do while, and everything. We are going to cover everything of every one of them. Okay. So we have written our first for loop. Let's start with if else statement. Okay. Now let's see. Let's start with if else statement. For example, we are going to declare an integer. Let's say integer a equals 0. Now, if a equals, so we are gonna declare a if statement. If statement means अगर ये चीज हो रही है तो हम ये चीज करेंगे. Okay, so let's just go with if a equal 0. Okay, what this is, it's these are operators. Okay, what operators are? Okay, let's just go with the operators first because that is, I think, more easy to go with. Okay, so we have different types of operators. What operators are is they uh, are used to either declare something. For example, where are okay, there is no good representation of operators. Okay, let's just do like this then. Okay, so there are different types of operators. They can be arithmetic shift operators, relational operators, bitwise operators. So what an operator is, it is something that performs an action, okay, on a number. For example, if we are using equal to operator. Okay, here this is assignment operator. It means it will assign the value of 0 to a. Okay, and then there is arithmetic operators. What arithmetic operators are? If I go with in b equals 32, let's just do this. Okay, what arithmetic operators are? They'll perform arithmetic operations on two numbers. Okay, if a minus, if I do, they are plus, minus, divide, multiply, all of that. You'll understand. And these are not that big of concepts. Okay, if I do this, it is key. It will subtract b from a. Okay, if I do this, it will add a and b. If I do this, it will multiply a and b. Okay, these are arithmetic operators. Now, uh, these are arithmetic operators. Now, these are equality operators. Okay, this is what I call them. The exact word is different. What they do is they check if a equal. If there is double equal, it will check the value stored in a is equal to this value or not. Okay, it is gonna return a boolean. Okay, it will either return true or false. If it is true, the if statement works. If it is false, the if statement won't work. Okay, there is another that is not. Okay, if a not equals 0. Okay, this is what operators are. And there are also operators, which is, for example, b is 32 now. And what I can do is b plus equals 1. What this does is this increments b. Okay, it will take b and it will increment it by 1. Okay, if you see, if I run this, it is going to increment this b by 1. It's making it 33. This is how it works. Now, another way of doing this is using plus plus, and it is going to give me 33 as well. Okay, these are quick overview on operators. They are nothing much. If you come to Java T point once, you'll learn everything how they works, and this is simple. Okay, there's nothing. Shift operators means it will shift the binaries. Don't worry, they won't come into your exams. The main one are when you write code only. Okay, so these are multiplicative. If you've got to take modulus, this is modulus operator. Okay, let's talk about modulus operator. What modulus operator is? It is gonna give you a remainder. Okay, okay, let's go. If b is divided, okay, let's make a 2. If b is divided by 2, what will be the remainder? If b is divided by a, what is going to be remainder? It's going to give me that. Okay. If b is divided by 2, 32 is completely divisible by 2. So it's giving me 0. Okay. If I make it 33, which is not completely divisible by 2, it is going to give me 1. Okay. See, it gives me 1. It gives me the remainder while we divide. Okay, the next is let's go to the next one, which is okay. These are operators. Now let's just go to the control statements. We are going to implement only those are important because one short video is already 40 minutes ahead. After editing, it might be a little less, but we are just going to use those operators, those conditions which are hard to implement. Okay, so what if statement does is there's a we pass a condition. If that condition is true, if statement works, otherwise it's false. Okay, so there are two ways of doing it. If we can check like this, if a equals 0 or something like this, or we can even pass these things to it. If true, okay, it is gonna work every time. Okay, this statement might not work every time. If a will not always be equal to 0, it won't work like a holds 2 now. It won't work. Okay, I copy this just to test this. Now it won't work because a is not 0. Okay, this won't print. Okay, but if I make it 2, it will work. It is gonna give me 1. Okay, let's remove this. And the other thing is, you can always use this. If a not equals 1, it is still gonna run because a is 2 and it is not 1. So it is gonna return a true value. Whenever this condition is true, this is gonna work. Now, sometimes there are multiple conditions. Okay, sometimes you might want to, if a not equals to 1, you want to do this. Okay, it's always true or always false 1. So let's just do this. If a equals 1, we are going to do this. Else if a equals 2, we might want to do something else. Okay, अगर ये हो रहा है तो we'll do this, अगर ये हो रहा है तो we'll do this. Okay, this is how it works. And also control V. Let's see. We are gonna check if is divisible by 1, or let's do 2. Okay, now if I run, which one is going to run? This one. Now it's going to give me, okay, what the hell, why is it giving me, oh yeah, it's 33. Let's make it 32. So it's giving me 0 here, since the second one is running. Okay, if I make a equals 1, if I make a equals 1, it is gonna give me still 1 because everything is divisible by 1. So let's make it 33. uh, let's make it 33 and make a equals 2, and we can always do this. Okay, we are going to increment this a here, so it's going to run. Okay, it won't run. What happened? Okay, a is 1, it is gonna give me 0. So you know how it works. Okay, so this is this, and if there is nothing, if the state this is not true, this is not true, and we just want to make a default case, we use this else statement. This will run if this is not true, this is not true. Okay, we can use multiple if else is in between. Okay, else if we can use multiple of them. Okay, like this. We can do this, and we can go on like this. Okay, but this is too lengthy. Okay, you not always want to write this. So sometimes we use switch statement. Okay, so we are going to declare a, and we are going to type switch, and we switch statement takes this variable here. Okay, we are going to pass a. For example, we are going to pass a. Okay, and let's do this, and here we are going to say case 1. If a equals 1, this is what it says. Okay, case 1, if, sorry, my bad, if a equals 1, what we are going to do, we are going to print the value of b. Print ln, let's do b. Okay, and we are going to break is something that is gonna get us out of the switch statement. Okay, otherwise you'll be stuck in here. It is gonna repetitively do it. Okay, if a equals 1, we are gonna break out of it. If it is 2, if case equals 2, we are gonna do okay, let's do system. We are gonna print the value of, we are going to print the value of a. Okay, this is what it is, and we are gonna break from it. And we are also going to create a default case. This means this else which we used. Okay, in default we are going to say if it is not equals, we are going to do just system dot out print ln, and we are going to type in not equal. Okay, guys, I'll be back in a moment. So not equal, QUAL. What is the spelling of it? Yeah, that is the spelling of it. Okay, let's run. What should it print? It should print, I think, the value of b, which is 33. Okay, it prints 33. Now if I change the value of a to 2, it is gonna print 2. So this is how it works. This is switch statement. Now then comes loops. Okay, if you want to do something repetitively, okay, if you want to print, if the value of b is changing continuously and you want to print it. Okay, so for int I, so this is the syntax for loop. Let's, okay, you will know for loop because you might have ever coded in, so we'll just go through. Okay, let's go to for loop. So this is what for loop is. It takes 3 parameters. Okay, initialization, condition, and increment decrement. Okay, what it does is, you can see the for loops get initialized. It checks if the condition is true. If it is true, it's gonna if it is true, it's gonna run. Else, if it is false, it's gonna break out of the loop. Okay. For example, here you can see int I equals 1. Okay, it's declaring int I 1, and whenever I is smaller than 10, it's going to run the loop, and after every iteration, it's going to increment I. Okay, so the starting is going to be 1, then it is going to increment it 2. Okay, so first it starts here, checks this condition, runs this, and comes back to I plus 1. Okay, this is how it works for loop. This is the syntax for the for loop. It's simple. It's same as C, C++. Don't worry about that. So this is for loop, and you can nest these loops. Okay, if you can do this. This is first for loop, and this is second for loop. So that you can print these cool patterns and everything. Okay, we are not going to go too deep into it because we are running out of time. We have to cover the whole Java, and we are still in the very starting phase. Okay, this is for loop. Then we have while loop. While loop in while loop. Okay, in while loop we have a condition. If that condition is true, it's going to run continuously. Okay, for example, if you can see this example, int I equals 1 while I is 10 less than 10, it's going to run, and after every iteration we are incrementing I. Okay, it is good to implement a forever loop. If you want to run it continuously, you can use a while loop. And there is another loop, that is do while, and there is a difference that comes to a question comes, what is the difference between while and do while? So the difference between while and do while is whilst loop uh, might not run once. Okay, let's see the syntax of do while first. Okay, where is it? Where is it? Do while loop. Okay, so what happens in do while loop? Do while will at least execute your statements once. Okay, even if the condition is not true. If I say I is 0 and it is greater than 100, it is gonna run it once. Okay, it will run it one time. But while loop, if the condition is not true, it won't run at all. Okay, but do while will run at one time. This is the main difference between it, and you can write the syntax and give an example that is going to give you good enough marks. Okay, that's going to give you the complete marks for that. That's the difference between do while and this. And then comes break statements. Break statement means if you are running in a loop and you use break in between. Okay, for example, if we are doing a loop, let's type in while true. Okay. Why I write Python syntax? I don't know. While true, okay, it's going to run infinitely. Okay, and what we are doing is we are going to increment the value of a on every iteration. We are going to increment the value of a, and we are going to print it. Print the value of a. So print ln a. Okay, we are printing the value of a, and now we are going to use a if statement. If this a is greater than equal to 1, what we are going to do? We are going to break out of the loop. Okay, let's change this. If a is greater than, okay, let's make it. Okay. Yeah, let's make it 10. Okay, if a gets greater than 10, it's going to break out of the loop. Okay, it won't run forever. If I run this, it is not going to run infinitely. It's just going to run till 11. Okay, as soon as a gets 11, it's going to break out of the loop. This is what break statement is used for. Okay, simple. Continue means if there is a fake case scenario. Okay, if I equals 5 and there comes some error, you want to continue. Okay, you don't want to break out of this. It will skip the rest of the code. Okay, for example, let's see. I'll say if a, okay, let's see, let's type it here. If a is greater than 5, we are going to continue. Now, what it will do, if a is greater than 5, it won't run this code. Okay, it is going to just jump through it. So we won't see this 5 here. Okay, let's see. Okay, why am I using NVTop? Okay, let's run this. You see, okay. Oh, my bad. Okay, what I did wrong here is every time a is greater than 5, then it is going to do this. So I'm going to use equality operator here. That if a equals 5, it's going to skip only one case. Okay, that's a equals 5. So it's not printing that 5 here. 4 after 4, it's directly 6. That's why we use continue statements. Okay. Comments and programs. This is okay. So we have covered the operators. We have covered the control statements. And okay, one thing that might be asked is ternary operator. Okay, so ternary operator is something we use. It is a shorthand if-else statement. Okay, if I have to write it in one line, what I can do is I can pass a condition. I'll say a equals 5. Okay, this is true or false. I'm going to use this question mark here. If it is true, it's gonna say do something like system dot out println 5. No, it's gonna do println a. Else, it's gonna do system dot out println nothing. It's gonna print nothing. Okay. Left hand side must be a variable. What do you mean? It must be a variable. Okay, let's see. What did I do wrong? Let's see if else is here. It should be here somewhere. Ternary operator. Did I forget this concept of did I forget the syntax of ternary operator? Yes, I did. Let's just Google it. Ternary operator in Java. Guys, I am not a native Java coder. I code in Python and Dart mainly. So that's why I'm having a hard time. Okay. So this is what it is. Okay. It should be this. Okay, I've implemented the same thing. Okay, yeah. I'm not storing this value anywhere. That's the error. Let's make it boolean boolean c equals this. Okay. A less than 5. Still type mismatch. Okay, what is this gonna be? Int. It returns either 0. Good. Type mismatch. Okay, guys, just Google it. I don't know what error is coming. Okay, leave it. Turner operator won't come. If it comes, just say that it is a shortened notation for if else, and just write this concept, and no one is gonna know if it works or not. Actually, it should be there, right? Okay, let's see. Turner operator. Let's copy this. I don't know what was the error, why it was not working. I don't want the max. Okay, yeah, max. It should be there. Integer. Max is not used. We'll use max. I won't use max. Okay, we are gonna call max. We are gonna call max inside this for loop. Remove this b and run. This is a messy code. Don't worry, I don't write this state of a code. Okay, yeah, maximum is 10. Okay. Ah, okay, so if this condition is true, it's gonna print this, else it's gonna print this. Okay. I was using a while loop condition, that's why it was not working. So we have covered this and this. Now we are gonna cover methods. Guys, we are gonna cover methods and then we are gonna shift to other things. Okay, so let's go to methods. Methods are functions in Java. Okay. To declare methods, what we do, okay, this is a method. For example, this main is a method. Okay, for example, if I want to declare another method, I want to add two things. Okay, so what I can do is I can type in the integer, the type of this. So I want to return an integer from a function. Okay, so function is something that takes input, performs something on it, and returns an output. That is what function is. Okay, there was this difference, I think. Okay, so we are going to return an integer and we are going to call this function. So the syntax is we first declare the type of return type and then we are going to name the function. We're going to call it add, not as, we're going to add, and this is how it works. Must return. Okay, this is how it is going to work. We're going to return 0. Now we are going to talk about parameters. Okay, functions have parameters. Parameters is something we can give it. Okay, if you recall maths, sin x, it takes integer and it returns something like that. Okay, if it is a positive value, it is going to return somewhere in between 0 and 1. Okay, so it can take parameters. I'll say int a and int b. Okay, it's going to take two parameters, a and b, which means whenever we call this function, we have to provide two numbers to it. That is going to be a and b. Okay, we are going to provide it two integers, and what is going to go, it's not going to do much. It's going to just return a plus b. Okay, it's a bullshit function. It's not never going to be used, but we are going to do this. Okay, so let's use this statement and remove the rest of the code. Okay, we are not going to, let's remove this. Yeah, okay, let's go. So what we are going to do is we are going to concatenate this. I don't know what happened to my hand. I'm typing something. 3 comma 5. Okay, add is not a function of this class. Okay. Okay. The scope, is it the scope or what? It cannot be referenced. Maybe this will work. This won't work. What is this? Why? Okay, so guys, there was the function was not public. If I do public, it's still not working. Why is it not working? Yeah, it should be static and public. That was the error. We gotta close the class. What the hell is happening? Why is it doing this to me? Okay. So now this should be public and static inside a class. So we are gonna do this. We are gonna run this, and it is gonna return the first sum. Sum. Sum is 8, which is the addition of 3 and 8. Okay, this is how we use functions in Java. I Okay, guys, this is just in one shot video. That's why I'm speaking. That's why I'm covering these concepts so fast. Okay, let's go ahead and let's see. This is how it works. Okay, so there are these are parameters in it. Okay, these are parameters which it can take value and it returns these things. Okay, it return this value. Okay, if we are not returning to it, it's going to give me another. Okay, and if we don't want to return anything, we can just type in void. Okay, now it's going to give me another that it can't return anything. If we remove this, it's just going to do the function. It's just going to do perform that function. Okay, and yeah. So there are some predefined functions and there are user-defined functions. User-defined functions are those functions that are defined by user. For example, I defined that add function. And there are predefined functions that are provided by the library itself. For example, this main function is a uh, predefined function. The length function which we used in array is also a predefined function. So this is a method about objects and classes now. Okay. Okay. First of all, before going to objects and classes, let's talk about the Java architecture. That is one of the most important things, and most probably you'll get a question from there. So what Java architecture is comprised is made of three things. Okay, it's JRE, JDK, and JVM. Okay, so what happens is we write the source code, that is this. Okay, this is the source code. Okay, we have written the source code, and as soon as I hit this, it gets compiled. Okay, it gets compiled into bytecode. Okay, compiled by Java compiler into bytecode. Now what bytecode is machine understanded code. Okay, it converts into machine language, zeros and ones, and that code is later on run by Java virtual machines, and Java virtual machine is run inside JRE, which is Java runtime environment, and your operating system executes it. Now what is the beauty is this bytecode and this JVM makes it platform independent. Now what happens is the okay, so we write C code now. C code is also converted into bytecode. Again, it is also converted into zeros and one binary form. Okay, once it's converted into zeros and ones, every operating system have different kernels. Okay, so kernel means the bridge between your software and hardware. Operating system and your hardware have a bridge in between. Okay, it converts. It tells your hardware how to execute code. Okay, now this the code in C is compiled on the system and it can run only on that system. If I compile a C program in Linux, it can only be run on a Linux system. Okay, it converts into a .a file. That .a file can only be run on a Linux system. But in Java, the bytecode, it is platform independent. Okay, what happens is that JVM, that is operating system dependent. Okay, for Linux there is a different JVM, on Mac OS there is a different JVM, and on Linux on Windows there is a different JVM. Okay, JVM is platform dependent, but the bytecode, once you compile it, for example, if you compile it in Linux, okay, you can take that bytecode and go on a Mac and run it on a Mac JVM. That is the beauty. That is what makes it platform independent. Okay, so this bytecode can be run on any operating system that have a JVM. This is how it works. Now let's go and take a look at JVM, how JVM works. What is the architecture of a JVM? So JVM have a class loader. What class loader does, remember I told you that this file name should be equal to this. Okay, so what happens is JVM takes a file and it looks for the file name and it's gonna detect the class here. Okay, for example, it's gonna look for this file here, which have a main name. Okay, and it's gonna take that main name and it's gonna look in the file where is the class main. Okay, this class, I can name these both something different. I can name them, I can name it ayush.java and class should be ayush then. Okay, it's gonna detect that and it's gonna load it into this class loader. Okay, then this class loader gives data to JVM memory. Now this is where method area is. Method area contains the variables, your functions, your everything, every data of your memory. Here, whenever your code is compiling and your code is running, okay, it keeps the runtime data here. For example, your variables during runtime, it's going to keep it in method area. Okay, it's class method area memory. Okay, it's going to keep it there. Then comes heap. Now this heap stores the data for the JVM itself. Okay, the Java virtual machine, it stores data for JVM here. And then comes stack. Now stack since Java is a multi-threaded language. Okay, we can perform multiple we can use multi threads and we can perform multiple processes at one time. So this stack contains those data. Okay, for example, there is a partial data. Okay, in between process, it stores that sort of data. Then comes native stack. Okay, it contains all the data about your compilation and everything. It contains the native libraries of Java, and it also contains the execution engine. What happens in execution engine is there is two things: garbage collector and JIT. JIT is just-in-time compiler. Okay, there are two, three things in execution engine. There is an interpreter, a JIT, and a garbage collector. What interpreter is this? Interpreter, we all know, it converts data into binary native code. Okay, byte code. It will convert that byte code into the code that is understood by that operating system, and that is run. But what happens is it executes code sequentially. Okay, so for example, we have a class here and we have another class. So what it will do, every time this class gets called, okay, every time we make an object of this class, it's going to compile that class again and again. Okay, so it's happening sequentially, which makes it a little slower. So to overcome the disadvantages of this interpreter, we have JIT. Okay, this removes the drawbacks of this and it compiles everything only once. Okay, so then this JIT helps to overcome this interpreter's disadvantages, and it stores whatever have been compiled already. Okay. Then comes garbage collector. Okay. In Java, in C, we don't have a garbage collector. So what happens is once memory is used, it stays allocated to it. Otherwise, we have to manually deallocate the memory. In Java, that happens automatically. Okay. The Java runtime interface automatically does it. Automatically removes the variable that are not being used. This is what happens in Java garbage collector. Now comes Java runtime environment. But this JVM, it needs a runtime environment. Okay, so runtime environment is provided by the Java operating system provides an runtime environment which can where JVM can be executed. Okay, this runtime environment provides an environment where JVM can be executed, and comes JDK, that is Java Development Kit. You might have heard about SDKs, software development kits. So it provides you all the features that you need. For example, your debuggers, your compilers, and everything that is provided by JDK to you. This is how Java compilers work. Now we are going to come to OOPS and objects and classes here, how it works and how we create objects. Okay, for example, if we can see, let me see. So I have told you how JDK architecture of Java works. Okay, so that is you should do it properly because a question might come from here, and it is really important of a concept. Then we have classes and objects. I have already told you a class is a blueprint. Okay, it is a blueprint for a object. For example, for animals, it might have four legs and everything like that. So that is a blueprint, and object is the allocation of memory for that. Okay, for example, if I create an object dog from animal class, it will give the length of that legs, the ears, the sensitivity, the behavior of it. That is what objects have. Okay, objects are really the things that have allocation of memory. This is the way we call an object. This okay, I don't know. Okay, let's leave this. Here we are gonna come to it. I'm gonna Okay. We are gonna cover objects and classes in another video for in next part. Okay. Okay. We are gonna do objects. This OOPS concept differently. Okay. We are gonna cover everything else, and then we are gonna do this differently because I think it is really important and it should be done in a good way. Okay. So your first chapter is complete for now, and we are gonna go to the next chapter, which is abstract classes, static classes, inner classes, and these we are gonna cover these things now. And maybe before it, we'll cover this object and classes in details, and then we're gonna cover Java classes and exception handling, and then we are gonna do IO packages and multi-threading and GUI and database connectivity. Okay, we'll see you in a few months. Guys, so now we are going to talk about exception handling. It's our third chapter. And what exception handling is, it is a way of making our code more robust and maintain a normal flow in our code. Okay, sometimes what we have seen is that we might do something wrong or an error may occur that will just randomly disrupt the flow of the program and it can crash it. Okay, so to overcome that problem, we use exception handling. What exception handling do is, it have a try and catch block. What it can do is it checks for exceptions or a error. If it occurs, it handles it, or it do not let that exception interrupt the flow of the program. So we are going to use Java T point again to see how Java handles these exceptions. It have great material. So we are going to go there. Okay. So what happens in Java? We have a try and catch block. Okay, so you can see here we have a try and catch block. What it does is it checks in try block that if any error or exception may occur, and then it handles it using this catch block. Okay, so we are going to implement this. Let's implement the thing. Okay, for example, there are multiple exceptions. Okay, for example, first we have let's call integer I, and let's try to divide it by 100. Okay, 100 divided by 0. Okay, This, if you know anything about math, you know that this is in programming, this is an okay, numbers divided by 100. Okay, if I run this program, we can see it will give you this that it is divided by 100, get rows and rows. So that we need to operate. Okay, you can just learn how to just kind of do this thing, and that's why see anything here. If I execute this, it won't work. This line will not execute. It is just gonna crash this program here. Okay, so to okay, this is I have knowingly declared this error, but sometimes you might not know what is happening. Okay, but you know that this piece of line can create error. So what we do is the line of code that we know might create an error. What we do, we create a try block in front of it. Okay, we just go and call that line in a try block. Okay, now what try blocks do is it checks and it tries to run that code. If a error comes, it throws it in a catch block that causes this exception E. Okay. It checks for any exception. If exception occurs here, it is going to record that and it is going to throw it inside this catch function. Okay. This catch block is a function that takes a parameter E, which is this exception is generated here. Okay. Now we can handle that exception. Okay. We might change the number. Okay. For example, if we say int C equals 0 and we are dividing 100 by C. Okay, we are dividing 100 by C. So C is 0. Okay, if this occurs, we will say that increment C. Okay, we can say increment the C and then go to then do this. Okay, we will try to handle this exception. Okay, for example, just to keep it short, we are just going to say that we are going to print that exception. Okay, our user wants to debug it, so we are going to print that exception. Okay, we are going to print this exception. Okay, okay, we are printing this exception that there is a 0 by 100. So this line is now going to execute. Okay, if you see, if I run this, you can see that it wrote that exception, but it ran the rest of the program here. Now in this catch block, we can try to fix this exception, but sometimes exceptions are not fixable. So we try to return that exception and maintain the rest of the flow of the rest of program. Okay, so I hope that you have understand why we use try and catch blocks. Now let's go to Java T point and let's study more about the theory. Okay, actually, whenever there is an exception, there are three types of main exceptions. Okay, one is checked exception, other is unchecked exception, and then third is errors. Okay, so let's start with errors because they are easiest to explain. What happens is sometimes our system might run out of memory. Okay, or there is a stack overflow error, or there is some sort of error that can't be recovered. Okay, so those type of exceptions are thrown in error category. That this will stop the program, but we will throw out that this error has occurred. So it becomes easier to debug the program. For example, we can't handle the exception where our system runs out of memory. We can't randomly put memory over there, no. So our program will crash, but we will know that it crashed because of the lack of memory. Okay, then comes unchecked exceptions. Unchecked exceptions are those exceptions that comes during runtime and they are not checked. Okay, they are randomly occurring. For example, division by zero or null pointer. Okay, we might have called an array, but there is nothing at the base address. Base address might have lost or anything, or array may have gone out of index. So those are unchecked exceptions, and they can be checked during the runtime. Okay, and then comes checked exceptions. They are throwable during runtime. Okay, for example. There is something wrong with your input output, or there is your SQL statements have returned something, there is an error with your SQL server or something else. So these exceptions can be checked during the runtime. For example, there is a file missing, that can be checked during the compile time, that a file may be missing. So those are checked exceptions. Okay, now one thing that you have to note is every time there is a try block, there must be a catch or a final block. Okay, there must be a catch block or a final block. Okay, you can't run the try block alone. These are five keywords that are mostly used in try and in exception handling. That is try, that executes some part of code that might create error. Catch is to resolve that error. Finally is run after try or catch. Okay, there's this nice graph here. I'll show you that. And then comes throw and throws. We'll talk about throw and throws in a while. Okay, first let's see the finally keyword. Okay, let's go to finally. Okay, this is finally block. Finally block is always executed. Okay, whenever there's an exception, you go to try, and if you are declaring a finally block, that is going to execute. Okay, if even if a error comes, that is not irreversible. That is not handleable. Okay, that we can't resolve, but still finally block is going to execute. Okay, so what happens here is program code and the exception occurs. If there is no exception, it is going to execute the final code. If exception occurs, we are going to try handle the exception. If it is handled, we are going to come to final block. Else, we are still going to come to final block. Okay. It is, for example, here we have this try block. If it causes an error, we are going to go to final block. You know, if this is, even if catch block does not execute, final block is going to execute. So that's why we use finally statement. Okay. Uh, this is why we use finally block. Okay, now let's come and see the hierarchy of exception classes. Okay, so these are mainly divided into three things. That's as I've told you: checked, unchecked, and error. So errors are those which can't be handled. Okay, for example, out of system memory, out of memory error, or stacked overflow, or virtual machine may crash. So these are errors. These are throwable. Okay, and then comes exceptions, in which your input output exception comes, SQL exceptions come, or maybe your runtime exceptions comes. Those unchecked exceptions. So they all comes in this throwable. So this is really important. This is the hierarchy of exceptions, and then comes throw. Now, throw is an exception block that is written to make your code more user friendly and easy to debug. Okay. For example, it creates custom errors. For example, in your code, you might be doing a election check. Okay, if a person is eligible for election or not, if he can vote or not. Okay, so here you can see that if age of a person is less than 18, it is throwing an error that person is not eligible for vote. Else, there is no error and it lets him vote. This is how it works. Okay, so it creates custom errors, and you can do both things. For example, there is a checked exception that there might be a file missing. So it throws the exception that file not found, and it says that the file here is not found. So it's throwing that file not found exception here. And then come throws. Okay, throws is wait a second. Where is throws keyword? Throws keyword is something that gives programmer information that an exception might occur. Okay, it creates, for example, you are executing a function. That function might give a exception. So it is run after that particular block of code. For example, a return type of a function, return type method, this method name. If this function throws this exception, what will happen? Okay, for example, here there is this void m function that might throw an input output expression exception. So if it does that, it is going to print that there is a device error. Okay, if a particular functions do that, uh, you can read this code. That one will make more sense. And let's check the difference between throw and throws. The difference is throw keyword can be used explicitly in code. Okay, anywhere you want to do, you can use throw keyword. Okay, for example, after any line, you can use this explicitly declared, that is throw. But throws keyword is used at the signature of a function. Okay, whenever a function is calling, we are using throws. Okay, that function might throw that error. Okay, there we use throws. You can read this. This is going to help you. Just come to Java T point, and after you watch video, just come to Java T point and read it once, and your concepts will be clear. So that's why we use throws. And there is this difference between final, finally, and finalize. Okay, final is a keyword that is used with variables. Okay, if you want to restrict the changing of that variable, for example, you are calling a variable that you don't want to be changed, you want to stop the access changing access to the that integer, use final keyword. If you want to use finally is the block we talked about that always executes, and finalize is a method in Java that is used after the execution of the program to collect all the garbage. Okay, just come and read this difference once, and your concepts will be clear. And I think we have covered the. Okay, let's talk about nested. Okay, nested try blocks in Java means sometime, for example, let's take a real life example. You might try to log in a user. Okay, for that you have to first check that are you connected to a server. If you are not connected to a server, you will throw a try block that checks the server connection. If it is connected to the server, it's gonna execute to the new block. If it is not, it is gonna raise an exception that you are not connected to the server. And then there can be a nested try block which says that if user exists in server, then go to next statement, else raise an exception that user do not exist. After that, there can be another try block that says that password matches or not. If password don't match, it is going to raise an exception that password don't match. So we can nest these try blocks in this way that makes sense to your program. Okay, and there are multiple catch blocks. Okay, for example, you are raising for example, you are raising exception. For example, there is a code piece of code that might raise different types of exception. Okay, you always not know that if it raises an arithmetic exception or a rebound exception. So you can call different cache blocks, and you can try to handle that exception differently. For example, if your array is out of bound, you can try to reset the index. If it is a arithmetic exception, you can try to do something different over here. Okay, in real code, you won't be just printing that this error has occurred. You might try to solve that error here. Okay, so this is what exception handling in Java is. This is the syllabus for it. We also use method overriding and overwriting in exception handling. Uh, so this is all for exception handling. Now we are gonna do IO packages, and then we are gonna do multi-threading, graphical user interface, and database connectivity. Thank you. Hi guys, so we are back, and now we are going to do the input output package of the syllabus. That is, just a second, let me bring it here. Okay, so we are going to do this. That is IO packages. In it, we are going to cover input streams, output streams, object serialization, deserialization, and filter and pipe streams. Okay, so first of all, I think we should discuss the need of why do we need input output for a file. So actually, sometimes we might want to save the data from our from our program. For example, you might be writing a program where you are okay. Let's take an example from machine learning. Okay, for example, you are writing a reinforcement learning model. In it, you train a model continuously. Okay, you have to do multiple iterations. Okay, and it saves the weight. So you got to save that into a file. Okay, maybe you are performing you are performing grading for students. Okay, so you want to save that performance. Okay, you want to save the grades for the students. So there are various things where you might want to save your data from the files. So Java provides us functionality with file input output streams. Okay, so output stream, first we are covering output stream. So basically, output stream is the way to write a data to a file. Okay, it is byte oriented as well as character oriented, meaning that you can store bytes or characters. For example, 65 by 65. If you are writing a number 65 and converting into a character, it is going to give you a capital A, as you can see. It saves. So let's just write this code. Let's see. Let's implement it, and let's see first how it is implemented. Okay, so we have our starting with the class main, and what we are going to do, we are going to import. First of all, we need Java input output. We are going to import this library where we are going to do file output stream. Okay, let's do file output stream. Okay, so this is going to give us the functionality where we can really, output to a file. Okay, so what we are going to do is we are going to write a try block. Okay, because sometimes operating system might not find the file or there may be any error here. So what we are going to do is we are going to call that file output stream, and we are going to create a variable fout where we are going to call that. Okay, so it's going to be a new file output stream, and the location for the file is going to be, okay, since we are here, I'm going to create a native file over here. So let's just do test.txt. Test.txt. Okay, just to make it visible, I'm going to increase the size. Okay, we have created this file here, test.txt. Okay, there's nothing into it for now, and I am going to do is, sorry, this life. Guys, by the way, exams are on our head. How are you feeling? Okay, so I am going to do dot slash test.text. Hopefully it works. I don't know. Maybe the file not found or something like that. Error might come. Okay, so we are gonna do, if there is an exception, we are gonna do it. We are gonna catch it, and we're gonna see what exception comes. So let's do exception E. We're gonna print that exception. System dot out. You all know the syntax now, right? Yeah. So we are gonna do right, E. Okay. So we have got this. Now we are gonna see if it is working. So we are gonna write to this file. Okay. So let's just do fout dot write. Okay, write means you can write anything to it into it. So we are gonna write a byte to it. Let's write 96. Okay. And 96 is the integer value for your small a. I mean, what do you call it? Capital A? No. What is the other one? Lowercase a. Yeah, lowercase a. So for lowercase a, it is 96. And whenever you are opening a file output stream, after writing it, you got to close it. Okay, to save memory, you got to close it. It is just to make the program secure and to save memory. So once we have closed this and this and that, so let's see. If everything happens, we are going to print system dot out. Will print that everything happened successfully. Successful. Successful. What's the spelling? I don't know. We are programmers. We don't give a shit about if we are typing. Okay, it's successful. So let's see the output. Okay, 96. Okay, I don't remember. What is the value for it? Okay, let's see. We are gonna do. Let's do something which I know. I know 65. 65 is okay. Okay, let's run. Again, successful. Let's see. Yeah, capital A. We get capital A. Should be 32. I don't remember. Okay, let's see. Shall we see it? Okay, we'll just quickly. If you all remember, we have ASCII chart. If you want to know what are the integer values for every character, just Google ASCII chart. Maybe you can see it now. Okay, so there is this complete ASCII chart that stores value. Okay, we are going to use this one today. Okay, so yeah, close it. Load up, load up, load up, load up. And let's see. Capital A is 65, small a is 97. Okay, I was doing this. Okay, it was 97. I missed it by one. Okay, so it's already, man, let's do this and run. So there was previously storing A and now we did it. So what is happening is it is overwriting it. Okay, it is overwriting the file here. It's not, it's not just writing it, it is overwriting it. Now, uh, this is the way we are writing bytes. Okay, if we want to add an array to it, what we can do is we are just if we want to add a string, sorry, if we want to add a string, we can just go str equals, let's say this goes, it's gonna get me pass, hopefully, the Java job. Okay, so it's there, but I can't just do this. Okay, it's gonna give me an error that it takes integer as an okay argument. So what we are gonna do is we are gonna convert it into a string. So what we are going to do is we are gonna say byte b. Okay, byte. It's gonna typecast it into it. Sorry, we're gonna just do str dot get bytes, and yeah. Now since we are getting get bytes, we are gonna do this. What this function is doing, it's basically converting every of these character into a ASCII, into a ASCII part, ASCII value. So we can just check it out. Okay. So the best thing about programming is you can check everything. There is no one stopping you. Okay. So first we are going to check, we are going to print what's in the value of B, and then we are going to write it to the text.api. Okay. I see. So, okay, it's printing the address for the B. I always do it. Right? I always forget I'm writing code in Java and you can't just print an array. Okay, so you can see 84, I think 84 is the value for capital T, is it? Let's see. 84, yeah, 84 is the value for capital T. So it's gonna store everything like that. Let me see. Just a sec. Let me bring back the light. Okay, so it's gonna print everything like that, and it is successfully added there. So this course is gonna get me passed in the Java exam. Good. So this is how input output works in it. Okay, we are also gonna look for input. So let's see how can we input. So this is how input output works, and there are various functions in it. For example, after output stream, if you want to close the file, if you want to clean up the connection, you use this file finalize, which we talked during the video for exception handling. And if you want to write, an byte of array, so we use the void write. And there are different functions for it, but for now you just need to know this one, that you convert it into a string and then you store it in. Okay, so this write function is what we use. So this is a Java file output stream. Okay, and let's talk about the input stream. So input stream is same as this. Okay, here what we do is we create an input stream and then we read. Okay, into I. Okay, let's see. Okay, let's implement it and let's undo it afterwards. Okay, so inside this output statement, I am going to delete this code, and instead of output, okay, we are gonna import file input. Sorry, file, not pike input, file input stream. Okay, so it's gonna be a file input stream, and it is gonna be, let's say, fn equals a new, okay, new file input stream. Okay, just remember the syntax. You don't need to do anything. Okay, and in file input stream, you gotta see this thing. You gotta add the file name, I think. Am I doing it right? Yeah, it's never closed. So am I doing it right? Let me just check. Yeah. You write the file name. Okay. If you are in Windows, you'll be using a backslash here. I am on Linux, that's why I'm using a forward slash. If you are on Mac, you are still going to use this. And this dot means current directory, and forward slash means the file is in this current directory, and the file name is text.txt. Okay. Now, okay, I'm gonna do is store this into a int I. I'm gonna store the value of pin in it. Okay, can I convert? Okay, it's integer already. I think. Char, maybe a string. So what am I doing wrong? Okay, I got a read. I forgot. Pin dot read bytes. Okay, cannot convert int to strings. Okay, let's see. I am just gonna do int. Close this. Okay, we got str. Let's just print str and let's see what is here. Print out println str. It's gonna be an integer, so we can later convert it into a byte code. Let me see. Everything is fine. Looks like everything is fine. Okay, let's save this and in fin is never closed. Okay, we gotta close the fin. The fin dot close to be safe. Okay, not NB top. Okay, I'm gonna run it here. And let's see. Okay, it's printing 84. It's just gonna do one thing. So read. Okay, there should be. Okay, I think there will be a function where we can read bytes. Okay, okay, read bytes b is used to. Okay, let's see. Byte. Sorry, b. Maybe this will work. No, it is not working. I don't know why it's not working. Mm, Nope. Okay, what is this? It is used to read b lengths from the string. Okay, okay, let's see. Okay, let's see. Okay, we are gonna do what Java point has done. Let's see if it reads everything. Oh shit, not bad. Uh, one shot bin main. Okay, why is it reading this? It should be okay. Yeah. The term outprint I when dot close. It should write something. I think. Okay, it's writing main. Why is it writing? I don't know. Yep, it is still doing that. Uh, when dot read is not equals to minus. Oh, to read all characters of a file, we got to do this. I forgot this. I haven't, I am not a Java guy, so I forgot this. It's like there was error. It was not printing everything. It should be like this. Pin is never closed, so we are going to do pin close. Pin close, and let's see. It should read everything now. Yeah. Why do I keep doing this? Yeah, this. Oh yeah, it was working before. You can see it was printing the T. Okay, so now this course is gonna get me passed through this exam. Okay. What I'll do is I'm just gonna do on next line printing. Print. I'm just gonna jump to the next line just to get it. Just write a backslash n to make it a little prettier. Yeah, this course is gonna get me out Java. Hopefully, it gets you all through it. So it's good. This is how you do file input output in this in Java. Now let's come to the other topic. Okay, let me just look at it. We have got this now. Object serialization or filter pipes. Okay, let's talk about object serialization first. So it's here serialization. So what object serialization in Java is? Okay, maybe sometimes you have a state of object that you want to store in a text file. Okay, if maybe you have an object, you have created an object. For example, you have created a person object. Okay, I have created an object where my name is stored, my phone number, and everything is stored, and I have created that object, and I want to store. I want to take the data from here to another computer. So Java provides us functionality where we can save that particular state of an object into a byte stream. Okay, what byte stream is, it can store it into a text file. Okay, so this particular process of serialization is this particular process of storing the state of an object into a byte stream is known as serialization, and the opposite of it means that's reverse operation where there is a serialization of an object, means it is stored in a byte stream. It can be converted back into an object. That is called deserialization. Okay, it is a very important thing, and since the nature of the Java, it is also platform independent, meaning that I can create a object serialization in here in Linux system, and I can use that in a Mac system. So it won't work. It'll work seamlessly. Okay, that's why Java is so much of a boost these days. By the way, guys, bring back your coffees. You got to study online. Okay, so. Uh, it have so this is what serialization and deserialization is. You can come here and read this. It's nothing much. So do you want to implement this or what? Okay, let's try to implement this. Okay, there are different functions here. You can read this. This is much of a jargon. I'm just teaching you the stuff that you need to remember to write an exams. Okay, just watch the video, and whatever I'm saying, just listen it carefully, and you'll be ready to give exam. Okay, you can write story in front of it. I'm giving you the basic concept, the core package, and I know you guys are engineers, so you guys can convert it into a story and write it in an exam. Okay, you guys will pass it, and to go deeper, we'll go it in a different video where we'll break Java into different parts, and hopefully I'll be bringing you one oops video where we cover oops the way it is implemented in industries. Okay, where we write real oops concepts. Okay, for the time being, let's continue. Okay, so you got to import this Java IO serializer, okay, serializable, and you got to declare it like public class student, which implements serializable. Okay, and since this is there, now this class can be serialized. Okay, so whenever you call this, you can write this. Okay, if there is this. Okay, so here you can see where are we writing it? String object right, like yeah, here. This object output stream is writing the object S1 into it, and it's flushing it and closing it. Okay, so we are importing everything. You don't need to do this every time. Okay, for serializable interface, you can just do it like this as well. So let's just implement this one. Okay, you not always have to write that class can be implemented that way. We can just write the output like this. Okay, so let's just go to Visual Studio Code and inside try block. Okay, first of all, what I am gonna do is I am gonna create a class. Maybe let's do a public class. Say human. Okay, human must be defined as own file. Okay, I am teaching you Java. Okay, so okay, this is not. Should be implemented in its own class. Should we implement it in its own class, or let's just create an object somewhere else. Like, oh, human dot Java. Okay, let's do human void human. Yep. Hmm. It is a okay. Let's just do it. Okay. It have a string value that is gonna be the name for this human, and it's gonna have something else. Okay, let's just do another thing. Let's say this is human, and what other category do a human have? Let's see, height and height. Okay, let's do it float. Float double. Let's do it double. Okay, okay. So there are two things this human have, and let's just do human. Maybe let's come void human. Will it work? I don't know. Okay, I forgot. It's gonna take a string name and a double height. My bad. It uses this. What am I doing? What's wrong? Okay, I got to see. I forgot the concept for this. Okay, let's see. Constructors. Why do I keep forgetting the syntax? Constructor in Java. Okay, constructor is something that initiates the class. Okay, whenever you start a class, a constructor is a function that can provide values to that can provide values to your class variables. It's a simple way of telling it. Oh, sorry, my bad. Super. It should be okay. My bad. Yeah, super. mm, what am I doing? Okay, let me see. Hmm, I don't know how to, okay, it's where okay this don't know. Ah, okay, that is mean. Why am I implementing this? We don't have time. Okay, I got it. This is the last time I'm wasting time. Okay, I promise. Okay, right. But you're gonna need constructor, so just read it. Okay. So this dot name equals to name, comma this dot height equals sorry height. Okay. Oh, sorry. Okay. This it should be this. Okay. So okay, can we import this? Import. mm, what am I doing? I don't know what I was doing before that was making it angry, but now it's fine. Okay. So we have created this human class. I'm gonna do this, and we are gonna call human. Okay, we are gonna say human Ayush equals human. Okay, so my name is Ayush, and this is gonna be invalid character constant. What did I do? Okay, yeah. So that was the error. Okay, my height is what 5'9". Okay, so it stored this thing. Okay, I created a new human Ayush. Okay, so this is the object that we have created here, this human object. Okay, this human class, and this is the object for the human. We are gonna talk about it in the last section of the video where we are really gonna talk about classes and objects in Java. Okay, so this is just an example for you that how it is working, and we are gonna use it later on. Okay, so that's why I write it. Okay, so what happens is now, okay, so if I want to save this object, okay, so what I can do is, not close, and let's see. We are gonna copy this code just for now. Okay. Mm, since I am not importing everything. So instead of importing a particular thing, I'm going to import everything from Java. I not everything. Okay, so we are importing everything. So as you can see here, we are importing everything. So we are gonna save Ayush there, and instead of file.txt, it's test.txt, and it's dot slash test.txt. So what is happening here? You can see is we know this syntax from before that it is gonna output as a stream. Okay, and this is creating an object output stream. Okay, this particular line here, it is creating the object into a serializable form, and it's gonna write this object into here. Okay, so this is what is happening, and if we run it, you're gonna see. Build failed, continue. Okay, what happened? Proceed. Human. Okay, exception. Uman. There is something. What happened? Okay, I think it. There is something. There is some sort of an error here. I don't know what is the error. It should not be working like this. It should be working. Five, six. Okay, there is some sort of an error. Okay, so for now, just know that this is how it works. I have to fix it. So I'll see about it how I can fix it. But for now, it's not working. And the same way, for the input syntax, we can do this and we can read it into a student variable. Okay. This is the way we can read an object into it. I don't know why will it not work? Okay, it did write into it. Maybe. Okay, let's do this. Let's close everything. Okay, we are commenting everything. Okay, also this. We are gonna come here and we are gonna say file input stream then equals file input stream. Okay, file input stream. This is gonna be the same as .txt. This and we are gonna say object read object input stream equals to be n equals to the new object input stream, which is gonna be fin. And let's see if I can read it into it. So it's gonna be a human and it can be okay. So let's say human Ayush. What is happening here? We are gonna read. We are not gonna declare human here. We are just gonna say we are gonna typecast it into a human. You know, into a human class. I think. Yeah, human n dot read object, and we are gonna read in. And let's see if it. Okay, there's some sort of something. Okay, SID plus sname. Okay, it should be name like that. Okay, sorry. Ayush dot name. Okay, plus Ayush dot height. I think. Okay, there is something. Okay, sorry, my bad. It is not gonna take any inputs. Uh, okay, it's just that. Okay, it is not gonna take any input here. So we are gonna close the in. We are gonna flush. Okay, not flush. My bad. It's gonna be closed. We are gonna close this here, and we are gonna read out the value of human. Okay, we are gonna print Ayush dot mm, name. Sorry, I am writing print. What the hell is happening to me? I am literally bad at this syntax. Print ln, and let's just copy this and let's just paste it and we're going to say height. Okay, will it work or not? Yeah, there is some sort of error here. Let's printing human new human. It should be working. I don't know what error. Okay, so there is some sort of an error, but it should be working. I'll fix it if I can find it before uploading the video. But for now, we are not going to waste the time. So we are just going to comment this code and let's go ahead. Let's see. Okay, so I have told you about serialization and deserialization works. There are different methods. So you now know how to implement it and how it works and what is the meaning. Okay, that is the meaning. You are either reading an object or you are writing an object. Writing an object means serialization and reading an object means deserialization. Okay. So we have covered deserialization here, and this now we are going to come to filter and pipe. Okay, so if we come here in Java IO, we can see here pipe reader and writer. Okay, so what pipe reader and writer basically is, it is a way of writing characters, stream of characters into a file. Okay, it basically uses multiple threads. Okay, so it's the same. It's quite same as this, but in that we use bytes. No, here we don't use bytes. It directly writes the character stream. Okay, so it's the same. We import from pipe reader and pipe writer, and we read and we can also write. Okay, they are most likely interlinked. They are connected to each other, reader and writer, and we call a thread and then we run it. Okay, so this is how it works. It's same as reading and writing through input output, but the difference is it writes a stream of characters and they are linked and it uses different threads. Okay, So this is pipe reader and writer, and then there is filter writer. Okay, so filter writer is an abstract class. Otherwise, it works same as the piped writer, but it is an abstract class, so it hides the inner workings of the inner workings of your functions, and it just shows the data that is relevant to the user. Okay, so it's pretty much the same as the pipe reader and writer. So that is it. If you want to, you can come over here. There is not much to it, so we are not going to cover it into great depth. So we have covered our Java input output here and implemented it. So our chapter fourth is also complete. Now we are going to come to chapter five, where we are going to learn about multi-threading and then graphical user interfaces and database connectivity. So let's jump to multi-threading now. Okay. Okay. So guys, now we are going to cover up the multi-threading with chapter 5. So in multi-threading, we are going to see how what is the life cycle of a thread and how threads work. Okay, so first of all, let's talk about multi-threading. What multi-threading really is. Multi-threading is a way of executing multiple processes in a single, executing different processes simultaneously. Okay, it is a thread is a lightweight sub-process that processes a very small unit of data. Okay, so there are two ways to achieve multitasking. It helps you achieve multitasking. Okay, nowadays in phones we all use multitasking. We watch YouTube videos and simultaneously we are doing some other work. We might be editing a Word document or something like that. Okay, so they all help in the multi-threading helps us achieve multitasking. Now there are two things in it. One is multiprocessing and other is multi-threading. Now a thread belongs to multi-threading and it is a lightweight process. So multi-threading helps us achieve multitasking. That is one of things. And threads are independent, so they don't interfere with each other. They don't block user. For example, if I want to print something from my printer, I necessarily don't have to wait for my printer to do the work. I can edit another PDF during that time. Okay, so you can save a lot of time because a lot of operations are happening simultaneously. So that saves a lot of time. Multi-threading is basically done mostly used in games and animations. Nowadays, we are seeing more of uses of it. Okay, one thing that multi-threading and multiprocessing uses a shared pool of memory. They don't allocate memory area to save memory. Okay, they don't allocate different memories. They both use the same memory area. Okay, now let's talk about multitasking. There are two ways to achieve multitasking in Java. One is process-based multitasking, and other is thread-based multitasking. Process-based multitasking has an address in the memory. It allocates separate memory for each process, and it is a heavyweight process. It is heavyweight, and it costs a lot of computation to perform a task. And switching from one process to another process takes a lot of time, and it's hard. Okay, basically, process-based multitasking is more of a heavy weight of a thing. It consumes a lot of resources. Whereas thread-based multitasking, thread is a very lightweight process, and they all work in a same memory pool. Okay, don't allocate memory for different threads. Okay, all thread use the same memory location, and the communication between threads is very low. Okay, so it don't take much of a time, so it is faster. So now let's talk about what a thread really is. It is a lightweight subprocess as it's written, and it is a smallest unit of process. Okay, you might be adding a number and you might be dividing a number. So that is what it is. It breaks down into very small parts. Okay, and threads are very independent and they use a shared memory area. Okay, that's what all of it is. I'm constantly saying the same terms, multi-threading and this and that, because it's more of a very complex concept, but it's compromises of those same words, and they have a lot of jargon in it. Okay, so as you can see, Java have a thread class that basically helps you achieve multi-threading. And this thread class have following so many methods like start, run, sleep, current thread, join thread, get priority, and all. Okay. So there is so many methods. You can come and read them if you want to, but they are not important. The important ones will be covered. Okay. So this is what threads is. Now we are going to see what is the life cycle of a thread. Okay. So a thread can exist in 5 states. It's new, active, blocked, waiting, timed waiting, and terminated. Okay. New thread is when a thread is created. Okay. when a thread is created, there is no process. It does not execute any process. It's just a new thread. Okay, you have just created it. So that is the new state. Okay, you just created it. It haven't ran anything yet. Okay, then comes the active state. In active state, it is divided into two parts. One is runnable and other is running. Okay, runnable means the thread is runnable. It may be waiting for its turn, or it may be scheduler may have assigned some work to it, but it is still it is not currently running. It is in runnable state, means it have been assigned the work, but it is waiting for another thread. Okay, that is what a runnable state means. It's waiting for its turn for the CPU. Okay. The other one is running, where thread actually has gotten the CPU and it is working on it. Okay. The thread is doing the work. Okay. The thread is currently executing its work. Okay. That is runnable. Now, scheduler prioritizes. There are different algorithms to prioritize which which thread should be executed first. And as we have talked about JVM architecture, there is this heap that stores. There is the stack that stores the values of this multi-threading. Okay, then comes the blocked-in waiting. Blocked-in waiting state means, for example, if a thread is inactive for example, if a thread is waiting, okay, let's consider two threads. It's the same analogy I'm taking from Java Point. Let's consider two threads, A and B. Okay, A is already there and it is executing. Okay, it have to print something on a printer. Okay, so A is currently printing. So B also wants to print some data, but B have to wait till A completes its printing. Okay, so B have to wait. So till B waits, that particular part is known as blocked or waiting part. Okay, because we have to B have to wait until it frees up the printer. Frees up the printer. Then comes timed waiting. Actually, what happens in timed waiting? Sometimes that A in the previous example, A might reach a critical section where it is taking a lot of time. So B might go for starvation. Okay, B might be trying to terminate. Okay, for that particular time, we can sleep the thread. Okay, timed waiting means sleeping the thread. We can say that okay, it might take that much of a time, so we are making the thread sleep until it gets its way. So the thread won't starve, and the memory won't be deallocated. And then comes terminated. It is divided into two parts. One is if the thread has completed its job, so it will terminate normally, or there is an abnormal termination where there might be an error, or exception might have handled, so something like that has happened that may have crashed the program, or something may have crashed that particular thread. So that is abnormal termination. So these are the five states. You got to write a story when you're writing a physical exam for it. So if you want to, you can just come here. But I've given you a good overview of how threads lifecycle works, and there's this implementation given here. For example, here there's this class. There are two ways of implementing threads actually. One is you can say the class implements the runnable class, and in between you can call the thread and perform actions. Or the other one is you can explicitly say that actually Java Point has covered it. Okay, we are going to come to. So after that, let's come to thread scheduler. Actually, thread scheduler is something that decides which thread should be executed now. Okay, so there are different algorithms that decide whether which thread should be executed first. So it's divided into two categories. Either it is priority based or it is time of arrival. Okay, if it is time of arrival, it can be first come first serve. If thread ones come first, thread one will be executed. Then thread two, thread three, whichever comes first, it will be executed first. And then comes time slicing, in which each thread have been allocated some time that you are going to be allocated there, you're going to be allocated there. So this is the way. There are different algorithms. We don't have to worry about them that much because it's not in our syllabus. But it is a great, it's a good concept that we should know. And this is we have covered the life cycle of a thread. We have covered what multi-threading is and why we use it. And we are going to learn about thread creation in a while. We are going to see the programs. We have talked about the advantages and the issues. Issues are it may be a deadlock. Okay, for example, two threads might be working, and thread two there are two threads. Let's consider A and B. So B might be needing some data that is considered that A should be giving, but A haven't returned the value and B is already starting executing. That might give some error. So these are the issues. There might be a lot of issues, and the example advantages are that it reduces a lot of time, and that we have covered it here. Advantages, block the user, saves a lot of time, threads are independent and all. So these are the advantages, and we have covered the disadvantages as well. That it takes time and it's processor heavy, and it might. Okay, so you all can create the story again. So this is what it is. Now let's see. The other part is synchronization in Java. Synchronization in Java means how can we synchronize the threads so that they can use that memory efficiently, and what should be done and how it should be done. I am out of coffee now. I've drank too much coffee today. So synchronization is basically a capability of Java that controls the access of multiple threads to any shared resource. Okay, if there is a shared resource, for example, we are using a printer, it's gonna control the access how different threads can access that printer at the simultaneously. So it is prevent thread interference and consistency. Okay, so it the synchronization in Java won't let a thread block another thread. Okay, it is gonna synchronize them in a way. So there are different types of synchronizations that you can see, synchronized and these and that. Okay, so you can read these. They are not that big of a concept. And synchronization, I have given you an idea what synchronization is. So that is what it is. You can come and read these things. These are just over good theory. Here you can see this in this example. There is no synchronization. The threads are executing. You can see it's a table. Okay, it's writing a table till 5, and the other is writing a table for 100, and this is writing a table for 5. So what is here is happening is 5, and the next should be 10, but the other thread has written a table for 100. 200. So it's these are the table for 5, 5, 10, and 15, 20. These are the table for 5 and 100 is. So these two threads are running simultaneously. So it's printing the values in between. Okay. So this is without synchronization. If we synchronize this, what happens is first it executes the 5 table, and then it executes the 100 table. So that is what that is how synchronization helps. I'll try to cover the programs in the end of the video if I could, if you have enough time left. Otherwise, I'll share some link or something about this, or you can come to Java Point and read these programs. They have given it quite nicely. So we have covered, I think, we have covered the multi-threading in Java as well, because that is what our syllabus was. So we have covered everything in it. So we are gonna come and talk about GUI now, and then we'll go for database connectivity. And yeah, let's go on. Let's work. Hi guys, now we are going to work on AWT, Abstract Window Toolkit. It sounds like AWS, Amazon Web Services, but it is Abstract Window Toolkit. It is an API to develop graphical user interfaces in Java. Okay, now what a API is, we have talked about it. It is just a messenger which takes data from one place to another place. That is the need of an API. It lets you program very small things. Okay, uh, and it is a Windows-based application in Java. Okay, now here Windows is just a word. It is not only it's not only window dependent. AWT itself is platform independent, but components of AWT are platform dependent. Okay, how they are rendering and what are the differences. Okay, how they are rendering and what type of resources they are accumulating. They are platform dependent, but AWT itself, the whole API, is platform independent. It calls native operating system libraries. Okay, so what is the need for AWT? AWT helps us create graphical user interfaces in Java, which really helps AWT Java to shine. Now AWT is an older version. We have come up with Swing, which we are going to study as well, which is better for platform for graphical user interface development. Now AWT is a heavyweight library. It consumes a lot of resources, and AWT components consume a lot of resources. AWT itself is platform independent. You can run it on Mac, Windows, Unix, anywhere. Okay, it uses API to create components, and this is the AWT hierarchy. Objects get rendered on the screen. Component are the elements of your graphical user interface. For example, if a button, label, checkbox, these all are elements which you can, show on your screen. They all are components, and they all get rendered as an object, and they all are stacked on either a window or applet or a dialog. Okay, so applet is for browsers, but for window, if you are using a native if you are creating a native window application, you are either using a frame or a container. Okay, now a container is the place where you contain other elements. ठीक है, that can contain other elements. For example, a container can contain a button, a label, or anything. It can contain a lot of these together. That is the purpose of a container. And there are different container classes such as frame, dialog, and panel. Okay, so these all are container classes. They all have niche changes. For example, Windows don't have a border on a menu bar, but it contains a title. But panel do not even contain a title or neither a menu bar nor any other things. No borders. Frame contains a title bar, a menu bar, and everything. So there are a little bit of differences. You can read it if you want to. And component classes also provides us methods. You can add a component to a container. You can set the size of a container. You can set the layout. We are going to talk about layout managers in a while. And there is this visibility. It takes a boolean, and if you want a component to be hiding, it can do that. Okay, so there are two ways of implementing AWT in your application. Either you can extend the frame class, which is provided by AWT library, or you can create an object from frame class. Okay, now we are going to implement this. Let's come to our Visual Studio Code, and let's create a file. Let's call it GUI.java. Okay, that sounds a fun file. Java. Mhm. And my handy intelligence predicted that I might need this. Okay, we are gonna import AWT from Java, java.awt, and we are gonna import everything, and we are gonna use inheritance. So we are going to extend to this graphical extend frame here. So now what I'm gonna do, I'm gonna create a constructor for this graphical user interface. Let's create a constructor. Okay, now we got this constructor, and we are gonna create a button in it. Let's create a button B. Okay, let's call it button, small button. Let's create a small button B, and we are gonna go new button. It is gonna be a button type. Okay, and let's close this. And this button is gonna say, my name is okay. Hey, are you? This button is not used, so we are gonna create button. Okay, we are gonna set bounds to it. Means set bounds. We are gonna say it's position. Okay, it is maximized both about what is. Okay. Some okay, so we are gonna do this. Okay, this is its position. Okay, what is its x position? What is its y position? And what is its width? So let's make it a little thick one. Let's make it 17, and let's uh, add a height of say 35 pixels. Okay, so we got this. Now we are gonna add this component to our frame by using this. Okay, we have added it. Now we are gonna set size of a frame. Okay. Now this is directly referencing to this frame. Okay. These are directly referencing to this frame. So you don't have to explicitly use this. Otherwise, you will have to create an object from it. So I'm gonna create a frame. Let's make it big. Okay. 500 by 350. And let's set the title for the frame if you want to. The title. Let's set title as Ayush's frame. Okay, we got this frame, and we are gonna do set visibility. And of course, we want it to be visible. And we are also going to say set layout. Okay, for now, we are not providing any layout managers. We are going to talk about layout managers in a bit. Actually, layout managers are those managers that provide how we are stacking the different components in our containers. Okay, in our frame, how we are stacking different of them. So that is what the use of layout manager is. We are going to talk about it in a while. So first, let's create a main function so that our code runs. So let's do main function void main. It always happens to me. I don't know why. Why it keeps hating me. Java IntelliSense. I don't like Java IntelliSense at all. Okay. So let's do AWT. Okay, let's go call this is gonna be GUI. Let's make it a frame. Let's see GUIF, and it's gonna be a new GUI. And let's close it. This is this constructor for this. Okay, so let's save it and let's run it. Why is there an error? There should not be error. Yeah, here you can see it, and this is the button. Hey, Ayush it says. Ayush's frame it says. Okay, yeah, this is how it works. This is the button, and I made it really thick. It's like 70 by 35. So yeah, so this is what it is. This is how you can implement graphical user interfaces in Java. Now we are not going to code much because we don't have that much of a time. It's a one-shot video. Okay, so we have talked about how we can create buttons and all. So let's go and Okay, one thing, yeah, I almost forgot this. Okay, this is not, it is setting the button position on screen. Okay, this set bounds is to set the position of the button. Okay, X from left, right, and all. So this is there. Now let's talk about event handling. Okay, so event handling just means, for example, you are clicking a button. So when you are clicking a button, what should happen? Okay, so there are event listeners, action listeners we call them. So if you are dragging a mouse, there will be an action listener for mouse listener or mouse motion listener. So that is calling if it detects a motion of a mouse, it is going to call this event. Okay, this has happened. So what should we do now? Okay, so there are different action listeners. Like these are the function in a button you can add action listener where you can provide action listener class, and then what do you want to do when this comes true, what is going to happen? Okay, so this happens, here is a code. Okay, for example, if this button get clicked, there's something is going to happen. Okay, so this is what event listeners are in Java. Okay, this is called event handling. It's not much big of a thing. You just come once to Java point and give it a quick scan. There's nothing much in it. There are simple codes which we might do at the end of the video. Okay, so for now we have done this. Okay, event handling is simple. There's nothing much to it. Okay, let me see. Just a sec. We are supposed to do. Okay, we have done this. We have done this. Okay, let's do layout managers. Here we have layout managers. Okay, borders. Let me see. Yeah. So layout managers are different ways of arranging components. Okay, arranging components in your frame in a particular manner. Okay, there are different types of layout managers. They are they are used to position or size of a component. Okay, so there are different types of them, like a border controller. In a border controller, your frame is divided into five parts. Okay, there is either north, which is the top of the screen, then there is south, which is the bottom of the screen, east, which is the right of the screen, and then west, which is the left of the screen, and the center. Okay, so it's divided into these ways, so you can arrange them like that. Okay, in flow, in grid, there are rectangles created in screen. You can define how many rectangles you want and where you want to stack each one of your objects. So that creates a lot of this. Okay, here you can see this is border layout class, where this is north, south, west, east, and center. So this is how you can stack them. So this is layout classes in it. Okay, there are different types of them. Here you can see he's setting layout and he's making visibility true. So these is what layout managers does. There are different type of them. Let's see what flow managers do. One other way in a flow. Okay, in a applet or a panel. Okay, panel flow, one left, right, left. Okay, yeah. Okay, let me see. Yeah, this is how you can set in a flow. Okay, these all are created and it set the flow to flow layout, and these all are added in this way. Now, first is added, then second, then third, and fourth. So it's gonna stack them in from left to right. Okay, so first, second, third. This is how flow layout works. Okay, it's gonna stack them one after one. The way you add them, it's gonna stack them, and then you can set. This is the way, and flow layout right. Okay, you can set different types of layouts. Okay, there should be more to it. Yeah, you can set these functions. How do you want to stack them? Okay, if you want to do it in center, if you want to do it in left, if you want to do it right. Here you can see it's doing it in center. It's here they are doing it in left. Right, sorry, they are doing it here. They are using the right one. Okay, flow layout right. So it's gonna start it right. Here they are doing center. Here they are doing. I think they it have center alignment. It's default. Yeah. So this is how it works. There are other ones as well. For example, if you want to see the grid, the way you add them, okay, the way you stack them, they represent. They come that way. Okay, in grid, you can create. See, this is just grid, and they have not specified the way you want to do this. Okay, they have not specified the grid layout, but here they have given a grid layout, and they are saying three columns and three rows. So it's gonna stack them like this. Grid is basically one, two, three, one, two, three, and four and five. So that is the way. Okay, they are adding padding in between. Okay, so this is a gap, vertical gap, and horizontal gap. So this is these are layout managers. You can add it. If you have multiple components, that you need layout managers. Okay, we have covered layout managers as well, and we have covered components. We have covered event handling. Let's talk about applet now. Okay, let's go to applet, Java applets. Okay, now applets are used to generate dynamic content. They are okay. They are embedded in your. They are either ran on your browser or on your client side work machine. Okay, they are very secure. They have less response time, and uh, they can be executed on many platforms on browsers and as well as Linux and Mac OS. The only drawback is plugins is required to create applets in your browser. Okay, you have to install a plugin. After that, you can work with them. So this is how it works. There is a Java applet, then it hierarchies it inherits the applet class, and then this objects get rendered. Okay, so there are this is a important question. It comes in exams that says life cycle of an applet. Okay, first we have to initialize the applet, then it gets started, it gets painted, it's stopped, and it's destroyed. Okay, now there are functions to perform this application. If you are using a applet class, the applet class provides you init function which initializes the object, then it starts the object, then it stops the objects. If for example, you have minimized your browser, so it's going to stop the applet. Okay, there it's not going to consume memory, and then comes this destroy. For example, you have shifted to a new page, so you're gonna drop those objects. Okay, so destroy happens. Now you're like the applet painted is not here, so component class provides the paint method, so components get painted. Okay, so this is the life cycle of it. Just remember, initialize, started, painted, stopped, destroyed. This is the life cycle of an applet. And you Java plugin software is responsible for the applet life cycle. Okay, just consider of okay, let's wait a second. Applet is okay, just consider them as small components. Okay, they generate dynamic content. For example, a digital clock is a okay. For example, you have a 9 1 2 3. So each of these digits will be a different applet. Okay, so once it changes, it's gonna change. For example, 901. One changes into two. So this two and one they'll be a applet. So one gets destroyed, then two gets painted that way. I'm just giving you an overview, and you can it happens here. Okay, so there is a applet code. This brings in first class. This is HTML body, and after you install that plugin for your browser, your browser will be able to read this code where it says applet code first. It's not a native HTML tag. You must have a Java plugin. After that your browser will understand that this is that it have to read code from this class, and then understands what is there, and it's gonna render it in a 300 by 300 box. Okay, and this is as the first class which is gonna print welcome to Java. Okay, so once this gets run, it's gonna print welcome to applet in your browser. Okay, so this is how applets work. And let's see, we have JApplet. Okay, okay, let's cover Swing first. After that, we are going to cover JApplet. Okay, Swing is just as is another version of AWT. Okay, but in AWT, the AWT components are not platform independent. Okay, they are platform dependent. If it is Windows, it's gonna render in some other way. If it is Mac OS, it's gonna render in some other way. So in AWT, the components are lightweight. Sorry, in Swing, the components are platform independent and they are lightweight. Okay, uh, we import. Okay, Java Swing is from Java Foundation classes. Okay, and it is also used for creating graphical user interfaces, but is faster than AWT, and it is more preferred over AWT. Okay, the main difference is the components of AWT. Okay, you must know this difference. Okay, AWT components are platform dependent, they are platform independent, they are heavyweight, they are lightweight. It does not provide a plugin. Okay, now a plugin is a good thing and also a bad thing. If you have a plugin, you can customize the look and feel of your components. AWT does not provide a component, so you don't need to enable a plugin in AWT. But in Java Swing, you have to have a no no sorry, my bad. AWT in Applets you have to have a plugin, but it supports a pluggable field, but it does not support a pluggable field. It supports a pluggable field. Okay, you can create your own fields of a button. Okay, you don't have to be a platform dependent that it should render in a way. Okay, you have seen in Windows we have really square edges, but in Mac we have rounded edges. In Linux we have some bit of a middle way. So Java Swing you can be as specific as you want to do. Okay, so it have less of components, it have more powerful components, and are more powerful and more usable. For example, it does not provide a table, it provides tables as well. And we just for your sake, Swing is better than AWT. Okay, we always prefer Swing. It also does not provide MVC, which is model control view. Okay, you don't know what you are rendering, but here you know everything. So it is better, and since it is a part of JFC, which is Java Foundation classes, it simplifies the development of application development. Okay, it's better to write. There are similar hierarchies there. No one is going to ask you that. It also have the same components, okay, as AWT. The same functions. You can add a component to it. You can add size to it. You can set the layout managers. You can set the visibility and all. The same way you can inherit. Okay, it's the same. Just here, instead of using Swing, you instead of using AWT, you are using Swing. It gets better. Okay, easy to develop. So this is Swing classes. Okay, now it have different type of button. J button is just a labeled button. Uh, you have to know one or two of them because it might come as an example explain the components of Swing. So one is J button where it is a label button which is platform independent. These lines are there. Okay, I'm just going to give you a shortcut to remember these things. Whenever you are talking about a Swing component, just write it is a platform independent button, and it is a labeled button, and it is faster. Okay, and one thing more, the whenever you see a J, it is the abstract. Okay, it is an abstract class, so it hides the use working of the button. It just shows you the result. Okay, these are abstract buttons. You can have following functions like you can set an icon to it and all. So no J button. J label means if you want to add a label to anything, it is also abstract, and it is platform independent. It is read only text. Okay, labels are read only text. For example, it comes up there as, for example, this is a label. Okay, this is a label for a button. Okay, if you have a button and it says something like that, that is a label to a button. Okay, if they have this, these are labels. Okay, first label, second label, these are read only. You can't edit them. Okay, and you must know text. Okay, my internet dropped. I don't know why. Text field means input field. Okay, if you whenever you write a input in your button, there is this input. It's a single line text input, and a text field is a single line. The difference between text field and text area is multiple line, and text field is single line. Okay, text area is a multi-line. It displays the text. Sometimes we use text area to display some text, but it's mostly used for taking inputs. Okay, text area and text fields are mostly used to take inputs from user. It's a read and write only, and okay, you can see these are text areas. You can write blogs in it. And then comes password field. The advantages of a password field is it uses obscure characters. Obscure characters means whenever you type something, it's going to convert into it into a very funny looking icon. For example, you know, now it converts it into a dot. You don't see the exact word, you see a dot. Okay, checkbox, you know, checkbox means you can either click on it. It stores a boolean value. If it is checked, it's true. Otherwise, it's a false. Okay, simple, nothing much to be worried. No J table. You can create tables in it. Okay, like that. This is the way you can create a table. Okay, you need to it's to store data. You need a multi-dimensional array. Okay, this is a multi-dimensional array as you can see here, and it stores this data into this table, and you provide this data to this component, and you provide the number of columns. Columns here, ID, name, and this. This is it's gonna show on top, and this is gonna show the data like this. So this is your various Swing components. There's J progress as all. You don't need to know that many of them. I'm just telling you this because it's fun. You can create applications with it. You should try creating an application using this. Okay, not really high level, but just try to write one. Okay, so we have covered this and this. So we have covered these J frames and this, and we have covered Swing components. We have covered applet cycle. We have covered applet class. Let's talk about passing parameters into HTML. Okay, this. Okay, we are supposed to cover one more thing. That is, where did it go? Okay, layout managers. Layout managers. Applet. Yeah, JApplet. Now, JApplet means since we prefer Swing to AWT, okay, but Applets, normal Applet class inherits from AWT, but JApplets inherit from Swing classes. So it becomes better and more usable to, since all of the advantages of Swing components comes to this JApplet, okay, just know that. And there's nothing different to this and the other applet we have talked about. Just it gets all the features from Swing library. And we are supposed to talk about what? What is leading? Okay, we are supposed to talking about parsing parameters through HTML. It's gonna be an applet. It should be here somewhere. Yeah, parameters and applet. Okay, sometimes we might be filling a form or something, and we want to get the data back to our Java program. So we use this uh, parameter name message, and it's welcome. Okay, so if anything comes to this parameter, we can retrieve it. Okay, just write a story around this. It is parameters means getting data back to your Java program. We can get any information from HTML file as a parameter, and this is known as get parameter. Okay, we use this get parameter message. Anything that comes from this parameter can be retrieved into this string. Okay, we'll come here and it's gonna do that. This is all. We have covered the graphical user interfaces, and hope now all the best. Let's go for the next one. So guys, now we have come to our last chapter, which is Java database connectivity. So first of all, we'll discuss the need for database connectivity for our Java applications. As we all know, Java is used for Android app development, and we all know if we don't connect a database, what will happen? It's a very simple thing that we might have to connect to an external database that stores our data, for example, users information or our products information. If we are making our e-commerce app, our products, images, what's its name, what's its prices, and everything. So we have to keep an information, and we don't store it locally on a client. We store it in a server in a database. Okay. So that is what is the need for JDBC, which is Java Database Connectivity. Now, JDBC uses a Java API that connects to a server, that connects to a database. Okay. Now, what API is? API stands for Application Programming Interface. For now, just think of it as a messenger. Okay. Think of it as a dakia that brings you letters, and then you might write a letter back to your friend. Your friend have written you a letter, and you are writing it back to him. So it just gets data from here to there. There are different types of API, but we are not going to get into it. We are just for now just think of API as a Postman, and it stands for Application Programming Interface. Okay, it uses it to connect to a database and execute queries on the database. Okay, so one important thing that you need to have is the database drivers. Okay, JDBC drivers you need to have to connect to a database. Okay, there are mainly four types of drivers. That is a bridge driver, a native driver, a network protocol, and a thin driver. So what's the differences? This is a very old school driver. It is no longer in use. All have dropped the support for it. It had very long mechanism, and it was really hard to use and everything. So these are dropped. Java bridge drivers are dropped. I'll show you it. No, wait a second. I'll show you the exact thing. Okay, so this is how JDBC bridge drivers work. They had a bridge driver in between that have a device, vendor specific device, and that is going to connect to database. Okay, these are very slow, and they are not that much of a performance. Okay, they connect to a database with I don't yeah, they converts objects. Okay, they converts JDBC objects methods into function calls. So that is a very lengthy process, but it is easy to use. So they are very rarely used. Everyone have dropped support for it. For example, Oracle have dropped support, and they're vendor specific. So these are not in use anymore. Then comes the native drivers. They use native Java API to directly call to the database, and they're called native drivers. They have performance overleft over our bridge drivers, and but you need to install them on your client machine. And then comes network protocol. Now this is where servers are introduced. Okay, for example, you have a mobile device that connects to a server, and that server connects to a database. Okay, so there is no direct connectivity to the database, so that makes it a little riskier, and it is mostly used in real world applications. Okay, load balancing and everything is given to that server here. Then comes thin drivers. Thin drivers are the drivers which directly connect to the database. They are vendor specific, so everything is there. They are best performers, and but it depends on the database, and connecting to them is hard. Okay, so making it secure is also a very important thing which you have to do. Now, for connectivity, you got to do this. Okay, just remember these 5 steps to connect to a database. First of all, you need a driver class, which means the way you are a driver. Okay, just let me explain drivers. Drivers means think of driver as a instructor. Okay, so it gives instructions that this command should be used on database. See, database is working on SQL, and Java is a different language. To from Java to convert into that SQL statement, it is required a different thing. Okay, so driver is that big of a thing. You don't have to write it in exams. Okay, then comes create. You have to create a connection. I'll show you it in the example of the code. Okay, you have to create a connection, then you write a statement, you execute that statement, and then you close the connection. Okay, now this closing connection is very important. If you don't close the connection, some intruder might get into your database and all. So you have to be very secure while you are working with this. You have to pay twice as much attention. Okay, so this is how you can create a connection and all. We'll see a complete example of it. Just a sec. We are not going to implement this because I don't have any local database here. So that's why we are not going to connect it. But let's go to connectivity with MySQL. Okay, for example, here you are going to import a JavaSQL, Java.sql, and you're going to import everything from that library. Okay, now you're going to create a class, and just everything is same as before. Then you are going to import the Java drivers. Okay, JDBC drivers, you are going to import them, and after that you are going to create a connection to that particular using JDBC driver to your host of the data host of your database. Okay, here they are using localhost, which means it's 127.0.0.1. It is localhost. It is not a real IP address. It just loops back to your own machine, and then after slash you write the database name, which they are using Suno. I don't know why, and then you write the username, and then you write the password. Okay, they you don't write them like this. They are used in as system variables. Okay, then you create a statement controller. Okay, this is a statement controller that can create a statement. Okay, now just a sec, they had it where, okay, yeah, when we are going to cover statements, then this is going to be more clear. But they have a statement controller, and that statement controller executes this query. Okay, you can see this is SQL syntax. This query will be executed on your database, and if it is returning something, you can read it. For example, rs.next, you can read everything from there, and you can also write into it. So it's reading because it's select star. So it is reading database, and then it is getting result into this rs variable, and it have a next function which can until it's false, it's gonna read everything into rs.getString. And I don't know what they have stored in this database. Okay, so this is how your database connectivity works. You need a driver class, you need a URL where it is connected. Your local, if you are using your local host, if you have a local database on your system, it's most probably hosted on 3306 port. Okay, uh, if you guys are interested in networking, please drop a comment. I'll talk more about networking, because I don't think so. College teachers teach much about networking, and it is a very, very important concept. Okay, so this is what it's hosted on mostly. Okay, now we're going to cover to the statements. And that's the last part for this chapter. Okay, open up. Yeah. So here comes the statements. Okay, Java statement interface. It is the way. It is a way provided to execute queries on a database. Okay, it returns okay, this gives back a class of a result set. Okay, rs that we saw earlier. So it gives that whenever result comes, it comes in this form. Okay, so most common statement interfaces are execute query. Okay, it executes whatever your select query is. Okay, if you want to update anything into it, if you want to create a table, if you want to drop a table, if you want to insert anything, you use this execute update. Okay, it returns a int, and it returns a result set. And then if you want to execute multiple commands, multiple statements at once, you use execute alone. Execute, there is no update in it. And then comes execute batch. If you want to execute multiple, if you want to execute a batch of commands, mostly you use these upper two, and these two are not that much used. Okay, so now here you can see it's connecting to Oracle database with localhost, and these are the passwords. Okay, and then he's creating a create statement cursor. Okay, this is the statement cursor, and then he's executing delete that from here. So you can see he's using execute update statement, and here is using create statement. Okay, so create statement means it is creating this connection is creating a statement controller, and that statement controller is later on using to delete this row from there. Okay, and it is going to result whatever the result is, it's most probably going to result the number of rows deleted, and that is going to come over here. Okay, so this is how your database connectivity works. That is all we have in our syllabus here. You can see this is all we have in our syllabus. Just a second, let me check if there is connection interface. Yeah, okay, okay. This should be covered. Okay, this is important. Okay, so connection interface in Java is a way of connecting to the database. We have seen about it. We have seen the code for it. So here you can see this function returns a statement that it is create statement. Okay, It is a part of a statement class. Okay, so create statement. It is used to create. It is used to create statements that can be executed on SQL. They are SQL query statements. Okay, then create statement. If you want to type in a result type and concurrency, these are some functions. Okay, the main one is this create statement, and there is this commit. Okay, for example, if here now, where is it? In statement, you see we deleted this, but it won't affect the database. Okay, it will give you a simple version, but it won't actually commit on the database. Okay, to make it commit, you got to run this function after that. Okay, con.commit. You'll be running that con.commit. After that, your database will be there. And if you might have made some mistakes, so you might want to roll back, then you can roll back. And after every connection, after everything you have done, you got to close the connection to the database. Okay, these are some common functions for the connection interface. And if when you are these are some SQL related things. If you want to read the connection, uh, these are transaction handling. Actually, if there are two transactions happening simultaneously, then these are used. Okay, so you might know these from SQL, so I'm not going to cover them. And this completes your database connectivity in Java. I can't run this. Actually, I don't have a local machine here. My It's not connecting to my local machine. I don't know why. I don't have that drivers. You got to install them first. So as you can see, I tried to execute them locally, but they are not executing because they are saying I don't have the drivers. And since it's a one-shot video, I don't have time to install the drivers and all. So I'll leave you to this, and our last chapter is complete. Okay. Hello guys, now we are to end this video. Now we are gonna discuss the most important topic of this video, which is oops, and we are gonna cover the classes and the second chapter of this video. We have been postponing it for a while now. Let me show you the content. We are gonna cover abstract classes, static classes, unit classes, wrappers, and this and that, which all the jargon that makes you feel like you don't know anything about programming. But we are gonna cover it in a very realistic way. We are gonna talk the realism, and we are gonna make it good. Okay, now we'll be coding, and we'll be talking theoreticals. We are also gonna cover classes and objects and everything. So just hang in there, get yourself excited, get yourself a cup of coffee, whatever you need. I am already high on coffee. I've drank too much today, so I won't be joining you with the cup of coffee, but you should. Okay, go get yourself a cup of coffee. Okay. So now what are we so let's open up our Visual Studio Code, and let's open up let's write a new file, completely new file. Okay, okay. So we are going to name this file. What should we name this file? Okay, let's see. Okay, if you're into test.java. Okay, this is test.java. Okay, this has created one class in it. Okay, so this is a class. Now, what a class is? These keywords means we are defining a blueprint. Now, everyone talks a class is a blueprint. Now, what a blueprint is? Okay, uh, so what it is we define how we want to store data. Okay, and what sort of behavior that data will possess. That is what a blueprint is. Okay, for example, let's create something else. Okay, let's create another class. Let's create another class. Let's create a class name as human. Okay, so we are using, for now, hang in there. I'll tell you what this public and everything means. Okay, we are going to create another class which is going to be human. Okay, you see, this is another class we have created. Human. Okay. This always gives me an error. I don't know why it gives me an error and all. Okay. My bad. Why am I using a public in that? Yeah. So we have created a class public. We have created this human file in here. Okay. Human class. Now, a human will have a name. So he'll have a name. He'll have a name, something. Okay. He also will have a age. So the human will have a age. And what else? What else do you guys have? Okay, you might have. What else do human have? Maybe. Okay. For now, okay. Let's keep it this. Okay. Now, what a human can do. Okay, this is a human. Okay, this is a blueprint that he'll have a name, he'll have a age. Okay, he may be into a relationship or something. Okay, we'll create a bool. Okay, let's see. Boolean relationship. Is he in a relationship or not? Okay, this is a relationship. Okay, if he is in a relationship or not. Okay, So we are doing this. Okay, this is some data. Okay, so anything regarding to that particular group. Okay, consider class as a group. Okay, for example, consider students. Students. It is a general term. Okay, that you are a student. You can be a student of anything. You can be a student of CS. You can be a student of anything. It's just a general way of categorizing. Okay, uh, you can back propagate to it. For example, you can think of human as a person, but when some humans share the same trait, we call it a class. Okay, when there is some when there is generalization, when we can generalize something, we call it class. Okay, this is what happens in real world. For example, we if we study, we all are students. So student is a class, and it have members. Members are students which study. So students is a class and it have a member, a particular student is a member of a class, which is students. So this is what happens in real life. But in computer programming, we create a class and we create objects from it. Okay. So what here is happening is we are creating this human class. Okay. It have a data, it have data, for example, it have a data that is name. Okay. It have integers. For example, we have created name, age, relationships. Okay. Now going ahead, human also perform some actions. Okay, so uh, for example, if you ask someone what is your age, they tell them age. Okay, so we know how to create methods. So it won't return anything. It is just gonna be like this. So it's gonna be age. Okay, so void age. Okay, now one thing, you can't repeat the same thing. What's so I'll go like what's your Okay, let's use camel case. Upper camel. Okay, what's your age? Okay, we have created a function. What's your age? Okay, whenever you whenever you ask a human, he'll return his age. No, he'll tell that I am this many years old. Okay, so you can do like for example, you say you'll return. What will you say? You'll say that I am this many years old. So computer will tell you that I am this many years old. Now we are using this keyword over here. Okay, this keyword. We're going to talk about this using Java T point. For now, just remember that this keyword returns the current state of that particular object. Okay, once we create an object for this human class. Okay, once we create a human from this human class. Okay, this will return this particular keyword. Whenever we use this keyword here, it will return the current state of it. Okay, for example, if I create two humans from it, one is Ayush, other is for example say Harif. Okay, one is Ayush, other is Harif. Ayush is 19 years old, Harif is 21 years old. Okay, if we create two humans from this particular class, and whenever I call this, if I call what's your age for Ayush, it is gonna return 19. Okay, because that particular variable stores what? Uh, that particular variable. Oh, what am I saying? Okay, calm down, Avish, calm down. Okay, now Ayush's age is stored somewhere. So Ayush's age's state is 19. So it is gonna return 19. But when I call the same function for Harif, it's gonna return what? It is gonna return me the age of Harif, which is 21. Okay, now first let's talk about constructor. Constructor is a function in class that initiates the human. For example, we have this name here, age here, relationship. Okay, but how can you store value in this? So the most common way, the better way is we call a constructor on it. Construct For calling a constructor, you just create a function with human name, but you don't have to add a return type. Okay, constructor never returns anything. So you don't need to type in here. Even if you type here int, it's gonna say you have created a function. You have created a method with the constructor name. So you just call human, and you can take arguments into it. Okay. For example, I'm gonna take arguments. First is gonna be a string, which I'm gonna call name, name one. Okay. Okay, let's call it name. You can call it anything. Okay, it's just a constructor. So you can call anything. The best practice is to call whatever you have here to ask for this here. Okay, that's best practice. Okay, Boolean relation. We can't say anything. Okay, now we are gonna store this into here. So we are gonna use this because remember we have to use that state, current state. We have to store this value in the current state of that object. Okay, so we are gonna say this dot name equals to name. Terminate this dot age equals age, this dot relationship. Now see, just for intelligence, we use this. Now this dot relationship is gonna be equal to that relation. Okay, we have called here. So now what I can do now is I have created a class human. Okay, where we have a constructor. Constructor is something that initializes the class. Okay, now what constructor is gonna do? It's gonna ask me for a name, a age, and a relationship status for a person, and that is gonna store in a variables for class. Okay, so this is test. I am gonna do what I'm gonna do is I'll say that okay. First of all, we need a main function here. Public void main, and again it did the same thing. I don't know why my intelligence hates me. Okay, so let's create an object. Okay, it's gonna be of human type, and I'm gonna say my human name is Ayush. Okay, I am gonna name this variable Ayush, and it's gonna be new human. And you see, when I say human, it refers to this class, and it is starting with this function. Okay, it's asking me the name, age, and relationship. Okay, so here the name is Ayush. Okay, age of me is 19, and relationship status. I am not interested. So since it's a boolean, I should return false. Sometimes zero works, sometimes it doesn't work. Some languages support zero and one, some don't. Okay, what is the spelling for false? Relationship false. Yeah. So you can see Ayush, a human named Ayush is created. Now I'm gonna create another one. Let's go to my good friend of mine, that is Harif. Hi Harif, bro, how are you? So it's gonna be okay. It's a string. I've always used double quotes with the string. RF, he is also 19. I think he's 20, but I don't know. And is also not in a relationship. Okay. So we have two ones. Okay. For the sake of the video, let's make him in a relationship. Okay. Guys, don't worry. So there are two humans now from the class this. Okay. They both share the same trait. Okay. Now, when I call Ayush, okay, let's just call Ayush. Okay, I want to ask Ayush what is his, what is his age. So here we go. What's your age? What your okay? It should be what's your age? Okay, what's your age? And I'm gonna do the same for Harif. Harif dot what's your age? Now, what should be the values? Okay, okay. Let's make Harif a little bit older so that it returns the thing. Okay. Now, remember I told you that this keyword returns the current state of the object. Okay. Now, this object's current state is 19, false, and false. Okay. So it's going to return the current state of the object. Okay. Just to be clear, we are going to create another one. We are going to go change relationship status. Change relation. Okay. Okay. So it's going to take an input. It's going to take a boolean relation. Okay, it's gonna go this dot relationship equals relation, and okay, I got to use equals. Okay, so now what it is doing is it is gonna take a parameter that what is the current relation, what is the new relationship status of it, and it's gonna store it in the relationship. Okay, so let's print first of all, let's print the ages for Ayush and Harif. Okay, it's gonna okay. Why my build failed? I don't know. Mean what is it? Void human s.main. What is this? What did I do wrong? What is it? Why is it not running? Just a second, guys. Let me figure it out. the importing of the classes into other classes. So what I have done is I have get back to our human.java file which we have used before. Okay, so I have created the same human class over there, and I am using the main function for that class only. Okay, so I'm not importing a class into another class. I'm not extending or anything. Okay, so now we are printing the age of this. Okay, it is working. Okay, let me just make it a little clearer for you. So what I am gonna do is I am gonna do backslash n. You all know why we use it. We use it to get into a new line. Okay, so just it's gonna work now. Let me see. Okay, after that also a backslash n. To backslash n. Yeah, this should do it. Okay, let's remove the front backslash n. It's of no use. Yeah, you can see it's printing 19 and 21. 19 is for Ayush and 21 is for Harif. Okay, so we are gonna say we are gonna create one more function which is gonna be void change void what's your relation. Okay, whenever I go, I'll ask you. You gotta return what's your relation to her. What's your relation? And we are gonna say system dot out. We're just gonna print the current relationship status of that person. Okay, print ln why are you this dot relation. Okay, so it's gonna return the current state of it. Okay, so let's do this. Okay, let's check for Ayush first, and then we are gonna do for Harif. So let's comment this. Let's go for Ayush dot what's your relation? Not what's your age. What's your relation? Okay, and then we are gonna go. We are gonna change your change the relationship status for Ayush. So we're gonna say change relation, and I'm gonna say true. Okay, and then we are gonna say what's Ayush's what's your relation now. Okay, so here what is happening? Ayush is a single happy guy. He enjoys his life, and what happens then? He finds a girl. He gets involved, and he makes his life very sad and bad. So let's happen. Let's see what happens. Okay, so first he's printing that no, I am happy. I don't have a relationship. Then it's printing, oh, I got a relationship. So this happens. Okay, so this keyword actually prints the current state of that variable. Okay, now let's see for Harif. Harif is already in a relationship, so you know, he is already messed up. If you see, yeah, Harif. This is Harif, and he's already in a relationship, so he's messed up. Okay, Harif goes through a breakup, and he sets his relationship status to be false. Okay, like no, I am not in a relationship anymore. So what's Harif's relationship now? Harif dot what's your not age? It's your relation. Okay, what's your relation? Okay, my bad. It should be change relationship to false. Ayush grows from happy to sad. Harif grows from sad to happy. Okay, now you have learned. Okay, so in this fun part, what we have covered what classes are, how to create objects. Objects are just the just a single person for that class. Okay, we have students as multiple general equations for them, and for that a particular thing is for everyone. Okay, now we have talked about basics of it. We have talked about this keyword. We have talked about the state of an object. Okay, we have talked about the constructor for it. Okay, now let's talk about okay, what else do we need to talk about? Okay, let's talk about methods in Java. Okay, we have talked about it, but let's just go over it once again. Okay, for a method you got to tell what its access specifier is, what its return type is, what's the name of the method is, and the parameters and the method body or method signature. Here you can see it is returning nothing. It's not returning anything. So we are returning void. This is the name. Okay, let's talk about this one. Okay, it's returning nothing. It's the name of the method. It's the parameter type. Okay, it's gonna take a parameter that is gonna be a boolean, and this is the signature or the method of the or the body of this method. Okay, this is what methods look like. You can provide more arguments, or you can't provide more arguments. If you don't know how many arguments you are going to get, you can use, or you can always use a list of strings that is going to be args, and then you can query using 0, 1, 2, 3 like that. Okay, for every arg in this list you can do this. Okay, if you are a shell guy, If you have ever written in shell, you must have seen that we write we write like this Python 3 main dot py, and or maybe you are hacking, you must know that nmap fn. Then we provide some IP address to it, like 192 point something something something. So this what it takes, this for this function, it looks for first this argument, then this argument. Okay, so this is a different topic. If you want to know about it, we'll talk about it also. So this is how simple oops work. Okay, now let's talk about okay, let me check the syllabus first. Okay, so we have talked about this keyword. Okay, let's talk about super first, and let's talk about access controllers because they are easy. Then we'll go to into abstract classes and all. Okay, let's talk about the super keyword. Okay, okay. Before super, we have got to talk about inheritance. Okay, I forgot that. We got to talk about inheritance. Let's see, inheritance. It's such a fancy word, right? Inheritance. Okay, we all know that we all are gonna inherit the wealths of our fathers, but what does that mean? Okay, it means getting some feature. You not only inherit your father's wealth, but you also inherit his traits. Okay, how he eats, how he talks. You inherit those features as well from your parents, how you behave. Okay, so what inheritance means? Inheritance means acquiring property from your parents. Okay, first let's talk about the some terminology about inheritance. Terminology is class. We all know what a class is. Now let's talk about child class. Child class means the class which inherits from his father. It's also known as subclass. Okay, a parent class means the class which is getting inherited, and super class is also a type of parents class. These names are used interchangeably. Okay, parent and super and sub and child. So reusability means we are reusing those features. We don't have to write them again and again. Okay, so I think we should write a code and then we'll know more about it. Okay, okay, so here we have created this human class. Now we have created a human class. Okay, let's just take this out from here. Control X. Hopefully this works. That have given me errors in past. I don't know. I am more of a Python guy. Everything is so simple in Python to type and everything. No curly braces and everything. Also, I am into Dart and all. So okay, we are going to create a new class. We are going to say class. Let's call this class as employees, or let's call this class as students because students is what we are. Okay, we have created a students class. Now what inheritance, okay, I haven't talked about types of inheritance. Let's talk about that first. Okay, so inheritance means we are taking features from your from a parent. Okay, now we can take now sometimes we say that he's all gone on his father. Okay, so that is a type of a single inheritance, means he's just taking traits from one class. Okay, like here class A is taking all the methods from class B. Okay, whatever is in class B's method, it's taking it. Okay, that is single because there is only one parent. Where there is only one parent, there is a single inheritance. But then comes multi-level inheritance. Multi-level inheritance means you might have some of traits from your grandfathers, right? So it where there are more than two classes involved, like B have the traits from class C and A have traits from class B. Then comes hierarchical. Okay, you might have half of your traits are from your mother, half of your traits are from your father. So that is like you can inherit both classes B and C. Okay, you are A, your father is B, and your mother is C, so you can inherit from both of them. Okay, now sometimes your mother can have two childs. Okay, half of her okay, so you and your brother, they both will have same traits as your mothers or your fathers. Okay, and then comes hybrid. Okay, hybrid is like okay, it's more of like how many of you have watched Game of Thrones? House Targaryen. Okay, let's talk about Jamie and Cersei. Okay, this is Tywin, this is Tywin Lannister. This is Cersei Lannister. This is Jaime Lannister, and this is what do you call? What was his name? What was his name? His name was Joffrey. Yeah, Joffrey. Uh, but we all know this is so. What is here? Tywin Strait are carried by Cersei and Jaime. They both have a child, and that's Joffrey. Okay. So these are five types of inheritances. Now let's code, and we'll know for sure. So the way you inherit a class in Java is just typing, just only typing the word extends. Okay, student is extending human. Okay, constructor for human is not defined. Okay, one thing I got to do. This is very important, guys. Okay, whenever you are extending it in whenever you are inheriting a class. Okay, whenever you are doing inheritance, what happens is your function your constructor gets called. Okay, whenever you are referencing to the class, there will be a constructor calling. Okay, but here we have defined a constructor. We have not defined a default constructor, so we can do is human little just like that. Maybe it works now. See, this is also overriding. We're going to talk about it, but we have created a default what we have created a default constructor here. So we are saying whenever these things are not provided, just use this constructor. Okay, whenever name age is not provided, just use the simple constructor. Okay, so we are gonna give some default values to it. Okay, and default values is person one, his age is, let's do woo. Okay, let's make him 23. And yeah, let's make him happy. Okay, so by default the values are gonna be this. Okay, so students is inheriting from this guy, person one and all. Now, this student, okay, this student have all the features from human. Okay, these students will have all the features from human. Okay, let me show you. Not only talking, it's gonna have all the features from here. Okay, we have created this main method. Now what? We are gonna create a student. Okay, okay, give me students. Okay, students. It's gonna be, let's say, stu1. He's gonna be a new student, and let's close this. Okay, now this stu1. Okay, let's create some of his own methods, his own things. So okay, a student is from a college. So string college. Okay, let's see, the string college. We all are from, I don't know why, but we all are from here. Why is it giving me error? It's giving me error because I'm using single quotes. Whenever you are writing a string, you are supposed to use double quotes. And okay, we all are from this college. He'll have a section, or he'll have a branch. Okay, so he'll have a branch. It's also gonna be like, not string. He'll have a branch. Make this be small. He'll have a branch which is gonna be CSC. Okay, again, you know, Python habits don't leave you. Okay, now this student might have a function where he can change his branch. Okay, so change branch. Now what we are doing is okay, we are just doing a simple branch change for the student. What is here happening is branch this dot branch equals branch. Now what here has happened is the students this branch is gonna change. Okay, now this student will have these functions. Okay, he have a branch, he have a college. Okay, so we can okay, let's just create a main function. Okay, it's gonna be void print college, and it's gonna be like this dot out system dot out print lm. What are we gonna print here? Okay, guys, one thing I know that you guys are having a hard time understanding all Linux code. Just try to assume what is gonna be the output. Okay, just try to assume what's gonna be output and just try to code it once. Either just watch it and just try to code it. Just change the variable names. Okay, just change the variable names whenever you are trying to just execute it. The best way of learning programming is doing it hands-on. Okay, so just perform it. Okay, so we are gonna print ln college, and we are gonna make another function. Let's copy paste to do, instead of print college, we are gonna say print branch, and we are gonna say branch. And one thing you should know I have done wrong is not using this keyword. Okay, always use this keyword whenever you are doing the current state. Otherwise, it's gonna use the default state. Okay, and we never know what's inside the default state. Okay, so now what features will this student have? Okay, if I remove the access from the human branch. Okay, here the student is not a child from human. Okay, I have removed its inheritance from human. Okay, he's been this student class has been dismissed from his inheritance. There is no inheritance from human. Okay, so this STU1 guy, this first student, can do can change its branch, or can you know uh, print its college. So like pre-print branch. Okay, or okay, then he can change its let's see what it can do. It can change its change branch. Okay, he's not happy from CSC. He's gonna go to civil. Okay, why I keep doing this? Okay, it's gonna go to this and he's gonna print it again. Like now he's happy. He's in civil print branch. Okay, now it's gone. This code is gonna run complete. Okay, what happened? Yeah, this code is running fine. He's like he's in CSC. He's in this. Okay, but this student does not have a name. Okay, there is no name to this guy because we have not defined any name. Okay, name is for humans. Okay, there is no name for the student. But if I extend this, okay, if I extend this to human, what happens now is this student can inherit these features. Uh, it can have have a age. So, for example, I can say, "What's your age?" It will work because now it's "What's your age" is a feature of human, and I can access it here in student. Okay, if I run, it's gonna print 23 here. Okay, yeah, you can see it's gonna print 23 because 23 is the default age of human. You see, so this is how it works. See, this is how it works. So now we have inherited from here. Okay, now you can inherit from multiple classes like this. Okay, one before is Steven. Can I do human? No, that method human is not defined. What am I doing? I don't know. Okay, so let's go to super keyword now. Where is super here? Now, just for your reference, a super keyword is something. Okay, super keyword lets you do your parents' things. Okay, Mm, human. This will work. No. Cannot use super in a static context. Okay, what is that? Maybe. Oh, my bad. I can't write super here. Okay. It can't be used here, public static void, because the main function is static. That's why it was not working here. What I can do is, uh, void set. Okay. Okay. So what I can do is now. So I was just figuring out something. So okay. So guys, now what we are going to learn about the super keyword. Okay. Now, we might want to set properties for this student now. Okay, we might want to save its name. We might want to do this. Okay, so what we can do here is we can we can use super keyword. Super keyword is just used to reference to this to its parents. Okay, here I can go for human. Okay, for example, if I want to name the student, what I can do is name, comma, I need some age for the student. Okay, but and also I need a boolean that is going to be a relation. Okay. So now you'll be like, what is the point of asking for this? Because in student we don't have this now. But what super lets you do is super lets you reference the values from its parent. Okay. Now what I can do is, can I do this? Syntax error, super name. Okay, I can just reference them. Hmm, what am I doing? Print ln. Cut this part. Okay, 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 okay. So guys, now we are going to talk about super keyword. Here you can see what a super keyword is. Super keyword is okay. Sometimes we are in our child class and we might want to access our parents' class variables. Okay, here you can see we are accessing our parents classes functions. Okay, but sometimes we might want to know the name. Okay, we still don't know the name of this human. Okay, we don't know what's its name. Okay, so super is the keyword that lets you reference to your parent class. Now what I can do here is, if I want its name. Okay, what I can say is void print name. What I can do is I can you okay, I got a print, so I'm gonna write system dot out. You all know system dot out dot print ln. Here, what I'm gonna do is I'm gonna say super dot name. Now there is no name defined in this student's class, but name is defined up here in this Java class. Why is that important? Textiles in this human class. Okay. Now we are extending this human class here, so it's gonna print the default name. Yeah, where is it? It's gonna print the default name for the human class, which is default name is person one. Okay, so if I come down here and I say stu1 dot print name, okay, so it's gonna print the name of person one. Continue. I don't know why. See, it's printing this person name's first name. This is how your super keyword lets you reference to the variables of your parent class. Okay, it you can only reference to the variables. You can't set the values of them. Okay, so that is the use of super keyword. Now let's see. We have talked about super. We have talked about this. Let's talk about access control. Okay. Now access control is a fun place. We all need access control. Let me just see where it is. Where it is. Where it is. Where it is. Constructor. We have talked about methods, ops, and the static. Okay, we haven't talked about static. We'll talk about static first. Okay, I don't see access modifiers. Yes, they are. They are access modifiers. Access modifiers are those modifier are the keywords that lets you define the access for that particular class or a function. Okay, here you can see a private access modifier will not let anything be used out of that particular class. Okay, nothing in what is the member of a class won't be used outside the class. Okay, default method lets you specify access for at any level. Okay, by default access is only access is only given to a simple package in default. If we don't define a access specifier, it uses default specifier which gives only access to the only the package. Okay, then comes protected. Protected lets your class exist only by the package you are writing code in. Okay, if I am writing code in this class, why is it opening my Telegram? In this package, if I use protected here, so I think it is going to give me an error. um, I what is the spelling? Pro okay, it's protected. Yeah, see, it's going to give me an error because of something. Class can't be this. But if I use this keyword here, I can only access human inside this file. Okay, that is what. And public means anywhere we can import that package and we can use that class. Okay, here you can see within class we can access everywhere: private, private, default, protected, and everything. With private we can't define within the package, we can't outside the package, only with protected and public, and outside the package nowhere, only in public. Okay, so that is what it is. This is used for you can create anything. Okay, for example, if I want to make this protected, I can. Okay, this will work. Okay, now this can be only used where? This can only be used inside these three. Okay, outside the package of the subclass, within the package, within the class. I can't use it outside the package. Okay, this is how it works. Okay, this is the use of access specifier. I can't use this keyword. Okay, I was referencing it like this. No, even if I extend to this class, I can't use this. Okay, let's private. If I say it's, if I make it private, you know, if I make it private, this won't be accessible because I can't access it here because this is private. Okay, I can access it only inside the class. This is used to make data secure and get you, you know, get the access controlled. This will give me an error. If I make it protected, it won't give me an error. You can see if I make it protected, it is not going to give me an error. But if I make it private, it is going to give me an error. See, not private. Okay, now private, this means this can only be used inside here. It can't be used here. So hope you understand what I mean. Okay, we have talked about access specifiers as well. Okay, let's talk about final keyword. Okay, what is happening to my internet? Just a second, guys. Let me bring it up. Let's talk about the final keyword. Final keyword means it restricts the user access. Okay, whenever you declare a final keyword, the value of it will stop changing. No, it won't change the value. If a method is final, it will stop overriding. If a class is final, it won't inherit. It stop inheritance. Okay, that is what the use of final keyword in short. Okay, it's not in our syllabus, but I'm just telling you. Okay, if I use a final keyword, the speed limit is 90. It won't change. It's a fixed value now. Okay, it will not change. This is what it is. Now let's talk about static keyword. We haven't talked about static keyword. It's a static keyword, and we are going to talk about static classes and static keyword. Okay. Now here, static keyword is mainly used for memory management. Now, what that means is sometimes we in our classes we have variables whose value is same for almost most of the classes. Okay. Okay. One thing that happens here. Okay, let me check. Tell you one thing. We have created this human class. Okay, sorry, let's talk about student class for a while. We have created the students class. Okay, we have created this one student stu. Okay, what if I go and I create another of this? Okay, and another of this. There are now three students. Okay, now what is gonna happen in background in memory? This is gonna allocate memory for this variable, this variable, this variable, this variable, and this variable for three times for all five variables. Okay, for this and this, it's gonna create memory for these five variables one time here, two times here, three times here. So it's consuming. Okay, let's consider every variable to consume 1 byte. Okay, so it's creating 15 bytes worth of storage. Okay, but one thing that is that all of us are studying in Chandigarh University, and our branch is mostly, CSC. So we all are studying Chandigarh University. So why are we allocating Chandigarh University to three students three different times? Why don't we, allocate one memory for everyone? Okay. So what we can do is we can create it in a static function. Now what happens is, okay, it's static way. So static should be accessed in a static way. Okay. Okay. Okay, let's talk about these errors as well. Okay, so now we have made this word static. So now what is happening in the background is whenever this class is called, okay, the first time this class is called, it's going to create a memory pool for the class. Okay, class never uses memory. Class is just a blueprint. It never allocates operating system never allocates a memory for the class. But when we use static keyword, it creates a memory pool where it stores the static variables, static functions, and static everything. Okay, it's gonna store the static value of it's gonna store this statically there. Okay, so whenever this student is gonna access this, it's gonna access it from the memory pool of the class. Okay, now it says that static variables should be accessed in a static way, which means it wants this function to be static. Okay, so now I provide this function, I make this function to be static. Now this function is also stored in that static memory pool of the class. Now, what is happening? It's saying it cannot use static keyword. Now, I've told you that this keyword, okay, this dot which we are using here, is giving the current state of that object. But now remember, under the static keyword, we don't have the object. Okay, it's not the object's memory; it's class's memory pool. Okay, so this keyword is not valid here because object is not having this is not showing the object now. This function is of that memory pool. So that does not have a state. So if I remove this, it's gonna take it directly from student's memory pool. So we don't use this keyword here because there is no state. I can change the value of college. Okay. Static doesn't mean a fixed value. I can change the value of college for everyone, but it's gonna be saved in a static memory pool. That is what static classes means. If a class is static, it is stored in that particular memory pool. Okay, everyone can access that memory pool. That is this. That's why we use static. Okay, if I use static protected static, so this will happen. This means this variable is protected. This can't be used out of this function, this class, and that memory pool will be protected as well. So this is the use of protected. Okay, this is just we are not using. So we have talked about static keyword as well. So the same happens for static classes, static everything. Okay, they had a nice visual representation of it. Okay, they are also talking about static college. So here you can see these two objects are allocated memory in stack. So student one's memory, student two's memory, but they are not storing the college. Okay, the college is stored in class area, classes memory pool. This is stored, and they all are accessing college from there. This is what it is. This is how it works. Okay, this is how static memory works. Now let's talk about we have covered this. We have covered this. Let's talk about packages then. Let's talk about packages. Or we have talked about constructors, methods, class dynamics. We have talked about final keyword. Okay, we are about to talk about polymorphism. First, let's talk about packages. Then we're gonna go to this. Okay,
Guys,
packages. Guys, I hate battery powered things. I have recorded this video, and in the middle, my headphones they just went out of battery, so the whole audio was scrapped. So I am re-recording this, and now this is happening also. Okay, so we are going to talk about Java packages. Okay, consider a package as a collection of same classes, interfaces, or sub packages. Okay, uh, let's look at this tree. This will teach you everything. We talked about AWT now. In AWT, what is there? We have different classes. We have classes of components. We have classes of frames. We have classes of everything like buttons class, text fields class, different types of classes, checkbox class. All of those classes, when are packaged together, It is called as when we ship them together to a developer, this is shipped as a package. Okay, that package is known as AWT. The same is with Java's util package, which consists of array classes, maps classes, and all of those classes. These are util classes. For language, we have system, we have string class in Java. When these are called subclasses, okay, AWT, util, and these are subclasses. When these subclasses are wrapped together and sent as a package, it is Java package. Okay? So a package is just a collection of the same, okay, same parts. Okay, now let's talk about the code for it. When you are wrapping up different classes together, just wrap them using a package keyword. A package like this, package my pack, and just declare it at the top. You don't have to wrap anything. Just declare it at the top with the package name, and you will then you can directly Java using this line you can create a package and just use it everywhere you want to use. Okay, that is Java packages. We don't have to talk about it much. So we have talked about Java packages. Now we are going to talk about this thing, which is I think we have talked about originals. Now let's talk about Java polymorphism and the most overrated topics. People say that overloading, function overloading, method overwriting, they are the hardest parts. Well, they are the easiest parts, and we are going to talk about them. Okay, I think if we code, that will make more sense. Okay, first of all, let's just get an overview what function overloading is. Function overloading means changing the types of argument, number of arguments to redefine the function. Okay, if we change the number of parameters, we can use the same keyword, use the same name of the function again and again. For example, in our human class here, okay, in this human class, we might not want to, we are changing relationship status here. Okay, we are changing relationship status. Maybe I want to change the age, but I don't want to call every time. I don't want to use change the relationship, change age. Okay, my system should be, it should be intelligent enough to figure it out on its own. So what I will do is, I'll say void change again. Now, if I use this again, Boolean relation, and it is saying duplicate methods can't be used. So this is where function overloading comes in place. So I've told you about two types of function overloading. In one, what we do, we change the number of arguments. Okay, here there is only one argument. I'm going to provide it another argument that is going to be age. Okay, now this is valid now. Okay, this thing is now valid. So I can do this. Okay, it's a relationship, not a relation. I can do this and this. Okay, here my function will automatically change the age and the relationship status. Okay, but I can again do the same. Okay, I can say change uh, int age. Okay, so maybe I don't want to change the relationship status at all. I just want to change the age. So I can do this. Sorry. Age equals age. Now, what is happening here? This change is going to change the relation. This function is going to change the relationship and age both. This is going to change the age. Now, if I come down here, okay, this branch, okay, I'm going to remove all of this thing. And I am just going to create one student, not two. Okay, what this stu1 I am going to do is I'm going to change. Okay, okay. Shall we do it in the human class itself? I don't know. Change will to one dot change. Yeah, change works here. Okay, so I want to change. If I want to change relationship, I'll say relation false. Okay, the relation can be resolved to a variable. Okay, my bad. If I say false, it's gonna change relationship. Okay, if I say to one dot change, mm, you know relation to false and age to it was 28 by default. Now by default it was 28, but I'm going to change it to my age. Maybe I want to change just the age. Okay, I change it to 19. I can change the age to just the age. I'll say I am 12 years old. So now what is happening? It's gonna change here. It's just gonna change the relationship status. Here it's gonna change the relationship and age. Here it's gonna do this. Okay, let me create a function where everything is printed. Okay, what's your age? What's your relation? Void details. Okay, void details is gonna print everything there is to know about this person. So it will be system not out println name plus Ayush. Okay, sorry, not Ayush. It's gonna be this dot name. Come on, my bad. System cannot be resolved. So, okay, my bad. System. I can't use this here. Okay, plus I'm going to do this. String can't be converted into an int. Okay, will this work? My bad, my bad, my bad. Okay, I'm just gonna print this name, control C, control VB. Okay, three things: age, and let's say relationship. Okay, this should all be this. I keep forwarding. Okay, if you do Control Shift I on your keyboard, it is just gonna make your code beautiful. Okay, so in between, I'm just gonna say two one dot. What was the function name? I forgot the function name. It's details. Details. Control C, Control V, and Control V. Okay, I'm gonna set it to true by default. Okay. Okay, by default, let's make it true because of okay. So by default, our person's name is person one, age is 23, and relationship is 23. And relationship is true. What I am gonna do here is when I run this, yeah, continue. Okay, now what is happening here? The person name is person, default is 21, and we have changed the status from true to false. Default was true, we have changed it to false. Now, after that, it changed the relationship status to true again, and his age to 19. Okay, somehow its age is decreasing. Then we have changed the age to 12 here, and its relationship status is still true. This is how it works. This is function overloading. Now, what function overriding is? Now you can see this it is changing the way we are doing this. Now, function overriding means redefining some function. Okay, here we are using this. What's your relation? Okay, okay. Instead of what's your relation, let's see. Mm, what's your relation? Is there any function that a person might really want to change in it? Okay, okay. Let's see. Let's create a function like which we can overload. Okay, let's just overload. What's your age? Here it is just printing its age now. From here, okay, what's your? Okay, what's your is just printing here age. It's just printing the age. Okay, it is in class human and it's printing age. Now class student is extending human. So what I can do is I'll say void what's your, and I can just go and I can override this function. I'll say system uh, overridden. Now what is happening here? If a person calls it from for human class, okay, for human class it's gonna print the age. What's your function is gonna print the age, but for student it's gonna print it will print student. It's gonna print your student. Okay, when student is calling this function, it's gonna print overridden means maybe okay. Here for an example, okay, you have a class where mm, you might have a function that checks the grades for students. Okay, Okay, you have a teacher class. Okay, you have an employee class where employee can perform some certain actions. Okay, okay. You have an accounts class which every employee have, but only accounts persons can really check the accounts. So for other classes, we can override that function and we can say you don't have access for it. That's why we use overriding. Okay, overriding means we are going to change the inner working of the same function for different classes. Okay, that is function overriding. There's nothing good to show you there in that over here because our examples were lame. Okay, I'll completely teach you this complete oops in some other language and with real world examples. Okay, I'll show you my codes as well. So that is there. So we have covered Java polymorphism. Now, one thing, uh, you know, just a sec. I forgot what is runtime polymorphism. Okay, just a, yeah. Okay, runtime polymorphism is overriding over when you override methods. That is runtime polymorphism, and when you when you overload a function, that is compile time. That is compile time polymorphism is when you over load the functions, and when you override them, it is runtime polymorphism. I don't know why it's like that. It never makes sense to me. Why are we complicating the things that are always easy? Why are we making these things? Chemistry, but these are jargons which we have to deal with. So just keep it there. Don't worry. When just remember, whenever you are overriding a function, it's runtime polymorphism, and whenever you are overloading a function, that is compile time polymorphism. Okay, that is it. Again, the easier ways in function overloading you are changing the function here, but in over okay, it doesn't make sense. Okay, we have covered this as well. Now we have covered we have covered static classes. Did we? I think we have covered static classes. Have we? I don't remember because of the two videos. I am a little swamped right now. I don't know if we have covered it or not. We have covered super. We have controlled access controls. We have controlled this, and we have controlled polymorphism as well. Let's talk about abstract classes now. Okay, abstract classes is one of those things that you really can't see the implementation of. Abstract classes means you can see the implementation, but in on a bigger scale, it's really hard to show its examples on short scales. Okay, so there are two things: abstract classes and interfaces. So abstract classes means hiding the inner working of a method or a class from a user. Okay, just for an overview, abstract class means you will show only the data that is relevant to the user. Okay, you will only show the return to data from a function. Okay, you won't show what is happening inside. That is what abstract classes and abstract functions in Java means. That is abstraction process of hiding the implementation and showing the only the functionality that a user needs. Okay, just showing essential things. There are two ways to achieve abstraction in Java. One is interfaces. They are 100% 100% abstract, 100% they hide 100% of the data. Whereas if you use abstract classes, you can go from 0 to 100. You can show some of data and you can't. It depends on you what you want to use. My throat is so sticky right now. So points to remember, it's really important. Okay, you abstract class is always declared with an abstract keyword. Okay, you have to use an abstract keyword. Even if you are declaring a function, you have to use abstract keyword in it. Okay, abstract classes can have abstract functions or non-abstract function as well. Okay, you can have non-abstract methods in abstract classes. I call methods functions because I come from Python. And abstract classes cannot be initiated. Okay, where you can't create an instance of an abstract class. You can just call it. In Python, if you say a type of, it comes if you print an if you print a pointer, or if you print some memory block, or if you print a class. If you print a class, it says it is an instance of that, but that is not possible in abstract classes. Okay, you can't print the instance. And it can have constructors and static methods as well, and it can have final methods as well. Okay, this is the way you create an abstract class, and this is the way you create an abstract method in Java. Okay, you just use abstract keyword in front of it. Don't worry much about it. You just need to know that it's a way of hiding inner workings, and you don't have to care much about it. Then comes interfaces in Java. Interface is a blueprint of a class. Okay, it means that there are some static things that you want to use. Okay, in your program. For example, just a sec. If we go to abstract class here and we scroll real down, here, this is the interface. Interface means you are gonna say that these functions are gonna be, you inherit a interface. Uh, a class can inherit, can implement a interface. Okay, not inherit. It can implement an interface. For example, you say that interface A will have following four functions, and they'll do something, something, and something. Okay, these functions do not have a body, but they can have a body as well. So these function will be using for something and something. You are going to perform some actions using them. Okay, and those functions are implemented by class B. Okay, so what is happening inside this won't be given to B. Okay, what is happening inside these functions are not a concern of B. B just implements them. B just calls these functions. Okay, so that is what abstract interfaces are. Okay, if I go to the definitions of interfaces, let me just go slide up quick and let's see. The definition of interfaces, that is a blueprint of a class. It has static and constant methods and abstract methods. Okay, these won't be shown to it. Interface is just a mechanism of achieving abstraction in Java. There can be only abstract methods in Java interfaces. Okay, there cannot. It cannot have a. Okay, sorry, I was wrong before. It cannot have method body. It is just gonna say the name of the function, and then you later on in the body in the class implement the function, and it achieves total abstraction. It is also a ISA relation. I don't know what this thing is. Okay, let's Google it. Okay, it is just a relationship when a class inherits another class. My throat, it's okay. The way of calling an interface is this: you just use interface keyword and then write the name, and then in here you declare the constant fields, the abstract methods, and the default methods. Okay, that's it. These are interfaces. Just remember the difference between them. The differences, they have quite nicely done this. Abstract classes can have abstract and non-abstract methods. This can have only abstract methods. It supports multiple. It do not support multiple inheritance. Okay. In Java, abstract classes do not support multiple inheritance, whereas interfaces support multiple inheritance. Multiple inheritance again is where you are inheriting from more than two parents. Okay. That and abstract classes can have final, non-final static keywords, but it can only have static and final keywords. It cannot have it cannot have non-final keywords or non-static keywords. Okay, it needs to have either a static or a final variable. You can't use other variables inside this, and it must be declared using abstract keyword, and this must be declared using interface keyword. And yeah, you just come here and read this difference. Okay, it is important. And we have covered abstract classes as well. We have covered, I think, static. Did we cover static? I think, yeah, we have covered static classes as well. My bad. Okay, this is done. Okay, let's talk about wrapper classes. We have done interfaces as well. Let's talk about wrapper classes. Where are wrapper classes? Okay, wrapper classes are simple. Wrapper classes means if you want to convert a primitive data type into an object, you use the wrapper class. Okay. No, sorry. If you want to convert a primitive wrapper class into a object, you use a wrapper class, or otherwise if you want to convert an object into a primitive data type, you use a wrapper class. There is two things: one is autoboxing and unboxing. Okay, autoboxing means when you go from object to primitive, it is gonna somehow box it. Somehow it's gonna fix it, and it's gonna create it into a primitive data type automatically. It's not gonna convert it into primitive data type. It's just gonna create it into some primitives. And if you unbox a primitive, it's gonna give you an object. That is what it means. Okay. Use of wrapper classes are given here. It means you can read this. I am gonna see if I find anything that is worth explaining. Now my throat is really scratchy. Okay, change the value method and all. You should come and read this once, okay? That is all. For synchronization, we use wrapper classes. For serialization, for converting the data into, for converting a state of an object into text file or that, we use these for those. Okay, here is primitive data, primitive types for Boolean. We use this wrapper class for character. We use character class. Okay, and this is how it happens. If I want to convert this integer into a into an object of integer, I we use this function, which is from here. We use value of a, and it's going to convert it into a integer object. If I want to convert a integer, which is this, into a int, I use a int value, and it's going to convert it into a integer. Okay, it's some of higher level languages. We it is used. You are rarely going to use it. Maybe in good code or somewhere you might use it, but I don't know. I haven't never used this wrapper thing ever. Okay, so this is mm, we have covered this as well, and I think we have covered everything for Java. If you want anything, we can do this later. I'll if you want codes, I will give you an external PDF. But for now, we have covered Java. Everything in Java, whatever is required for your theory exams. So all the best for your exams, Ace. And even if you are not studying for exams, learn Java. It's a good language. A little old, 1995, I think. 19, yeah, Java was started in 1995. It's been few years in Sun Microsystems. It was developed in 1999, Oracle subsidiary, and yeah, used for developing Android apps, these apps, that apps. I used to have that Samsung phone. It used to come with some games, and those are also written in Java. I remember that logo from there. So